So the previous thing that we did was play with our AI models, and we actually made a model that is we took five model that was earlier trained, and we built on it, and we gave it our context, and it worked. So in this video, we'll cover Ollama. What is Ollama? How it works? How you can make it work on your local machine, and not a very powerful machine with or without GPU, it doesn't matter. Even on a low-end machine, it'll work very smoothly, right? Very smoothly. Let me open up my BTOP. So here you can see I'm just using i3 7th gen, nothing special, very primitive machine. It is there from, I don't know, 2008, 9. It is there like for generations. So you might be using either this or a bit more advanced than this. So Ollama will run without any bloat or anything like that. What you need is just a little bit of RAM if you're using Windows. And if you're using Windows, just set up a WSL through another video and you can follow along with this. Otherwise, you must have some deep knowledge or really surface level knowledge about terminal, how it works. And let's get started with Ollama. So yeah, Ollama gives us local AI models that we can, serve on our computers, on our machine without any internet, absolutely offline. It'll just have to be, bulky. You have to download models up to either 300 MBs or let's say 4 gigabytes. So depends upon what sort of model do you want and all that. There are different sort of models for vision, for, thinking, for just text and other tools. So popular options are there in the front page. You can select vision and all those things. So you can come directly to ollama.com and you will, on the models page, you will see this page. So you can install models. Now, we will, before jumping directly to this model page, first know how to download this Ollama. So we'll go to download section, and the downloading the Ollama is simply fairly very easy. So in my machine, I've already downloaded the Ollama. So if I run Ollama -v, I see my Ollama version is 0.20. So I already have Ollama. So I'll probably open up a Colab, Google Colab, so you can follow along even if you don't have a terminal or anything like that. What we'll do is we'll create a Ollama demo. Oh, sorry. I did not create it on book earlier. Let's create it now. And I'll, upload that to my GitHub repo and will link that in my description. So you can follow along very easily and all these resources will be available to download. Oh, not download. Ollama demo. Yeah. So this is a Colab, nothing new over here. You just have to connect a machine. We'll connect a machine that has a GPU. Okay, connect, change runtime, and we get a GPU. Now here you get some options, like you can either, run from here some terminal commands like this using ls. Like ls just list all the things available, all the folders and files. But this, bang, it is called bang or exclamation mark in English. This is used to signify in Jupyter files that this is a terminal command and it will run probably. It's allocating the runtime, means our computer is getting allocated, machine is getting somewhere allocated in clouds. Yeah, now it's connected. Now it will probably give me. Yeah. So this is the folder that is available to us. So if we open up a terminal in Colab also, and if we say ls, we'll see there that we have a sample data directory. Exactly the same output. So nothing changed. So what we can do is we can either run curl command over here, curl and all those script that Ollama has provided. This is a script, isn't it? And you're using it or running it using curl. So either do that, or you can go to directly and directly download the binaries that might be available for you. But since we are on Linux, Oh, Windows use something like IRM. So IRM must be something like curl, but in Windows. macOS must have used curl. Yeah. macOS and Linux are mostly similar in these aspects, like downloading and all. So if you can download in Linux, you can download in Mac. So instead of directly, using a terminal, how about I simulate my terminal through this? Yeah. So this must do exactly what we expect it to do, exactly like a terminal. And if we run it, it says this version requires ZSD extraction. Please install ZSD and try again. Okay. So will we get the same error? I think it will give us the same error. That is to install ZSD. Now this is a collab, so this is very restricted. So yeah, it's just I have to install ZSD. And if we are doing that, let's do it from Jupyter Notebook only, so that terminal, whatever you do in terminal will get lost after you change the runtime, isn't it? Yeah, as soon as you change the runtime, it will get lost. So probably use this, and we'll see if everything is very similar to it or not. So we'll first of all download the ZSD, in which I guess the curl will be there. So now it's downloading the Ollama Linux AMD tar ZSD. Yeah. So ZSD was needed and it was not there. So we installed it. Let's write this as this is called bang bang, and it simulates a terminal in what? Jupyter Notebook. Let's write down the domain directly, or extension, not domain. IPYNB, whatever. All right. Now, so if we use bang, it'll probably be same as saying the command directly in a terminal. So it's same. And what it's saying is system D is not running, unable to detect NVIDIA AMD GPU. Install the LSP, PCI and all those things. Install complete, run Ollama from the command lines and all that. So, well, it has detected a GPU and it's saying that it is not able to, I don't know, detect it or what. But Ollama is installed. So if we run Ollama over here, Ollama V for version, -V for version, could not connect to the running Ollama instance. Client version is 0.205. So yeah, this is our Ollama. Now if we say Ollama and directly jump in, now this is the exactly same thing that we will get after installing Ollama, right? So you can chat with the model after installing it. You can launch it with a OpenClaw. I'm just using down arrow, so nothing special. And why I'm showing you in this Colab, because it's very easy to replicate on your machine only. It's just a browser. You just have to go to Colab, make a account. It's for free, and you get a cloud PC for you. So yeah, so there are multiple agents that you can download and run Ollama with as locally, but we will chat with a model. And to do that, you can directly press enter, but then selecting models and not does not depend. Yeah, since we did not have a model earlier, it is telling us to install a model. So let's not install something outrageously big like 11 GB or 16 GB, because we are using cloud and there's almost 12 GB only, so we cannot probably use bigger model than that. So I know certain small models. Let me list them for you. So we came back to our terminal. You can replicate everything exactly the same in your Colab also. But I'll show you over here because it's interesting. So if I type something like Ollama, what do you expect? The same thing. Exactly like this. Chat with a model and all these same things. You can install and launch it. Nothing big deal. Now chat with a model. Since I've already installed, multiple models, it is showing me my last previous model I have talked to. So it's Gemma 2B. This is a small model, approx 1.6 GB or something like that. Now, if you have multiple selected models, what you can do is either directly say Ollama run and the model name, but then you have to remember the model name. Otherwise, sometimes it doesn't auto-complete it. The other thing you can do is directly type Ollama and then with a right arrow. All right, right arrow, you can go inside this and you will see all those models that you have over here in more and some recommended models that it says, well, install it or not. You can do it. It's your choice. But in more, you will see all these models that you might have installed. So 5.3 mini or let's say Qwen 0.5B is a very small model, right? As soon as you press enter, it will start loading it. And we are ready to chat. So let's do the same thing over here as well. So what we'll do is we'll close our terminal. We'll do everything from here. So we'll say, second of all, to pull a model, Ollama pull. Or you can just directly say Ollama run. And if the model is not there, it will pull it first and then run it for you directly in one command. But better way is to just directly pull it. And the model name. So we know we have a model called Qwen 0.5B. So we'll name it Qwen 0.5B. Okay, so how do you know we have a model something like this? Well, you go to the site and now since our installation is there, we have installed Ollama. We can directly go to models and see for ourselves which sort of model do we like or do we not. We can filter it out by newest models. So these are the newest models. We can see how many pulls are there. If you want more detail, just click on it. But this is a cloud model, so it will probably require login and all that. So it's not offline. If you need offline, don't use cloud models. Okay. So this is also cloud model. This is also cloud model, Gemma 4. But you can also install it, right? So there are installations models as well. So if you go over here, it says Ollama run Gemma 4 and it will probably install that model for you. That is approx of size 9.6 GB. We have a E2B, which is, a little bit smaller than that. And this E4B is same as the latest because, this is a marker over here that says it's the latest. And this Gemma 4 is what? Is a multi-model. It can take input of a text and will give you a response in text. It can also take an input in image and will give you an image response. So that's very good. Awesome. We'll use this Gemma 4. Right. So we can run it, we can pull it, but we'll use Qwen for now because this is a very small model and we want to. So it's pulling, I guess. Why are we not using the GPU? It's because NVIDIA or AMD GPU is not detected. So it is telling to install GPU dependencies, automatically or do it by yourself. So Ollama pull has already pulled the model. So now the second command that we want, or we could directly say Ollama run and whatever the model name is. Over here it's Qwen 0.5B. 5B. And I have never ran this on Colab like this. I ran it on terminal, so I know how terminal feels, but I don't know how this will feel. I have no idea. But let's open up our terminal sideways and let's see what we get over here as well. This is our terminal. We have multiple commands. Like if we do ls normally, what we get is a list of everything there. So this gives us a list. That's why I said ls. Now, if you have Ollama models installed, you can directly do Ollama and ls, and it will list all the models that you have. So we have Qwen 0.5V model installed. Okay, 42 seconds ago, and its size is approx 394 MBs. Think about it. Yeah, it is a small model, so it has all the disadvantages of a small model: lower context, more hallucinations, everything like that. But it's a blazing fast model. I think it's not able to run it from here, so let's not run it directly from here. What we can do is do everything else from terminal. We'll just use it to set up our environment so that we can say run all, and it'll probably set up the whole runtime, and we can use our terminal then after that. So we'll just use Ollama ls. This will probably just list all the commands. Yeah, so this is what we wanted. And now Ollama ls is there. We know we have a model, so we can directly say Ollama. All right. We can say run and the model name, since we know it, it's Qwen 0.5B. We can directly say it since we know the model's name. It's loading the model. Yeah, so it's ready now. It's saying send a message, which we can send like hi, and it'll respond to it. I don't know, this latency is because of the network or something like that, because this is such a low end model that it doesn't even require this much of a loading. Let me demonstrate. So which model is this? We can say bye to exit it. I'll tell you that, and escape to escape from there. Now, if I run Ollama, and yeah, so we were running Qwen 0.5B, and this is a Intel i3 7 Gen. Remember that. And if I say hi, see, that's called blazing fast. I know it's not good. It's, if you say, create a snake game in, let's say, HTML, standalone fine. I know it will probably fail, but see the response time. This is the response time, and yeah, it has failed. Why? Because it started creating a theory. So yeah, this model hallucinates because it's a so small model, like 300, 400 MBs. Our videos are getting more heavier than this model. So think about that. And yeah, and it's going on. Not bad. Not bad. I don't know why it gave us two response. Sometimes, small models, or sometimes Ollama does this mistake, but all right. Over here also it has given us the response that, hello, how can I help you today? And over here the same model is, well, going on and on. We don't know. Okay. So now we are something called Ollama interface. This triple arrow that you see is actually a sign that you are in Ollama interface. Okay. So what you want to do with this interface is it gives you some interactivity. Like when you press the forward slash and you write the help, you will see all the options that you get. You get the set option directly like this. You have to write forward slash and set, and you can set a session variable. Same with forward slash show. it'll show you the model information. We'll see each of these examples. All right, we'll run it one by one. We can use /load and it'll load a session or a model. Like you are running this model, you want to load another model as well, you can do that. You can save a model from this flag as well. Save, and it saves your current session. And this clear actually clears the session context. What is session context? The same conversation that you had, it'll remember it so that it gets the context of it. And it'll, for every message that you send to Ollama, it'll probably take your old messages as well as the newer instruction that you gave it. And it'll throw each of like the whole thing back to the model, and the model will proceed. It's like a probability machine running on, I don't know, hardware, and throwing out certain words that make sense in a probability. That's what it does. That's it. Nothing else. And this /by actually exits everything. And you can use / or /help like we did for the help for the commands like these. And you can use, # shortcuts to get help for keyboard shortcuts. So shortcuts are very essential part of our living. And we can't auto-complete it. So I pressed tab and it didn't complete anything. So we have a tab completion. If you don't know about it, well, you now know. If you press a tab, it'll probably auto-complete your whatever you were typing. But over here, you don't get that. So we have shortcuts, something like Control A to move to the beginning of line, like a home. So instead of pressing home will do nothing, but Control A will. Control E to move to the end of the line, exactly like the end button that you have in your keyboard. Alt B does what? Moves back one word towards left. Alt F moves forward, right one word. Control K deletes one sentence, the sentence after the cursor. So it's for editing purposes. All right. You'll edit certain message over here if it gets too long. How will you edit it? So now you can press home button, but that does nothing. Like I pressed it thrice and it did nothing. So now I'll press Control A and yeah. So now it's acting like a home button. We can press Control E to get to the end of it. So that's better for editing. We can go to Control A and delete the first letter like this. And then we can move on with our lives by pressing Control E and typing out the next messages. Doesn't make much of a sense, but this model also doesn't make much of a sense. And I would like to see what sort of response it will give us based on this, whatever this is. All right. Now, Alt B does what? Let's see. I am pressing Alt and B. So it moves backward one word at a time. Alt B, Alt B, Alt B. If you want to move forward, you can press Alt F, Alt F, Alt F. So these demonstrations are very easy to follow along. If you are just reading aloud, it'll probably be harder for you to visualize. Now the next instruction that we get is Control K. So it deletes the sentence after the cursor. So we don't have anything after the cursor. So let's get something after the cursor. Oh, I pressed something else. Okay. Go backwards. Now we have something after the cursor. And if you press Control K, it'll probably delete it. That's what it says. So it deleted it. I pressed Control K and it deleted. Okay. Now, if I press Control U, it deletes the sentence before the cursor. So everything, this random stuff over here will get deleted if I press Control U. So let's do it. Control U. Yeah, everything got deleted. So it's awesome. It's very awesome when you are using Ollama actually. Control W is to delete the word before the cursor. So Control W, I guess, just deletes a word, and that too before a cursor. So let's press Control W. Oh, I'm also shit. You know why that happened? Well, if you're using browser, don't press Control W. If you're using terminal, you can. What happens? either you can, get new tabs over here, or you see, you can press Control T to get a tab in browsers, exactly like this. Now to close these tabs, what you have is Control W. So if you press Control W, it will probably close these tabs. So that's exactly what happened in our case, where, we accidentally closed our Google Colab. So let's not press that while we are using a collab, but we can do it over here. And it's going on and on. And there are certain Chinese characters as well over here. Okay. Nothing more expected from Qwen. And it's going on. It's blabbering in itself. It's trying to satisfy itself only. This much of a message. Like, it's blazing fast. All right. And it's doing something random. Figuring out the same thing. Fast speed mode, snake will run. The same thing, same sentence, but I don't know, it is lost or something. What is this? So to close this, Control C, and Control C is exactly looks like this. So it means you have pressed Control C and it stopped. Now let's type something so that we can demonstrate how Control W works. You can also use arrow keys. All right, but if you use up arrow key, you will get the prompt that you have written above. If you press below, you'll get exactly like a terminal. But yeah, if you have 3 lines, then you probably have nothing left to do instead of going line by line. Okay, so if I press Control W over here, what will happen is word before this should vanish. This word. Exactly. So every word was similar. So let's write something different. And now press Control W and this YUI should be deleted. And that's exactly what happened. Okay. So we know this. Let's press Control K. Let's press Control what? F. No, L. Oh, Control L. Yeah, clears the terminal. Nothing bad. A moves to the home. F. Oh, Alt F moves forward 1 word at a time. B moves backward 1 word at a time. Alt A does what? Well, I forgot all the keywords. Doesn't matter. Now, since we did not use our terminal only, we made a notebook. So we can just run all these commands to set up our environment properly. So we'll say run all from here. That's a nice demonstration. We can just say run all and let's change the runtime because we didn't use our GPU. We'll try using the GPU next time, or probably we'll ask someone how to use GPU over here. This was the old response. Let's connect to the new machine with CPU only. Let's see. Open up a terminal. And if you've never used Ollama, or sorry, if you've never used Colab, you might be confused. Why am I saying like you cannot use Ollama again? Like, let me type Ollama and you will see what happens. So it says command not found. Why? Because, well, new start is like a new start. You have to do everything. So you're downloading it. Ollama is getting downloaded as it did earlier as well. Downloading Ollama Linux. 2%, 3%, and so on, so on. Okay. We should wait. Till then, let me show you magic. So we said question mark and shortcut. Oh, spelling mistake. Shortcut. Yeah, so we got our shortcuts available over here. Control W was to delete word before the cursor. Control U was to delete everything before the cursor. Control U. Yeah, Control U. I remember that. So I'm also learning it. Nicely done. Control L does what? It clears the screen. This is not just Ollama feature. This is like a terminal feature. Let me exit it from here. Or should I show you next time? I'll show you the next time. Let me open up another terminal. Nothing surprising. And let's fill up this terminal with stupid nonsense. Oh, what did we do? We typed something called GDF, and GDF was a, oh, it triggered git. Okay. So either we can say clear and it will clear the terminal, or we can say control L and voila, we have a clear terminal, and it just scrolled down. That's what happens. In this case as well, it just scrolls down. That's exactly what happens. All right, so this is a terminal functionality, nothing special. If you know and familiar with terminal, this will be not surprising for you. So control L clears the screen. Control G does what? Opens the default editor to compose a prompt. Okay, let's press control G. And it has opened up a well dedicated, NVM is something that I use mostly. And we can paste multi-line, multi-line prompts that we cannot do properly in So this is a multi-line prompt. It's not very easy. It is easy, but not very easy. So control C, we have used it. It stops the model from responding. And control D is to exit the Ollama, or you can directly say bye. That will do the same. So I don't want this to proceed. So I'll press control D. Control D. What's happening? Can I not do that? Am I allowed or not? Control D, control C to stop it. And yeah, control D worked when nothing was there. So if you have nothing, you can press control D. Okay, so it is installed and we still got this error. I don't know what this is. Okay. So we'll probably have to use Ollama serve to start it. It started earlier, but why didn't it start this time? Let's see what Ollama gives us. Yeah, so it works. I don't know why we are getting this sort of error message. I'm not entirely sure. Yeah, now it's working all of a sudden. So it's probably some sort of Google Colab behavior that it started working after we wrote Ollama in terminal. So it's automatically started serving in local computers. When you'll do that, well, in Linux we use systemd, and I'm not sure about Windows, but systemd automatically starts it if we make it a service. Or if it's not serving and you get a message where it says it's not serving and systemd is not running, what you can do is you can actually type something called Ollama. So, oh, wrong spelling. So, yep. And it'll, as you press enter, it'll start serving. Let's try doing it. So yeah, it's already bound to this IP. That's why it cannot serve it. What this message says, it's a very important message. First of all, it gives you this IP address. You are very familiar with 127.0.0.1, which is local host, which is 0.0.0. So this is just your local machine IP. The rest is called port, and this port is 11434, and it is bind to address that is already in use. That means our Ollama of always, if we don't serve it using some 8000 port, we have to do that voluntarily. But this is what Ollama already comes up with. Like white uses something called 5 4 3 2 1, isn't it? And yeah, like that only. Even Postgres has port it binds to something related to 5,000 only. And to check out what this IP holds, what we can do is directly says ss and slash tulnp, and then it will give us the whole TCP IP address that is there. And we increase its size. Now it's very clear. There are net ID, there are states, there are receive queues and send queues, local address port. So if you find 11434, you will see it's linked to Ollama, and the process ID is 14625. We can kill the process ID by saying process kill and whatever the process ID is. I don't want it to kill. So yeah. Now our Ollama is working, everything is working, everything is bind. And some other ports. Okay, so Jupyter server is running on this port. Python 3 is running on this port. Okay, nice. All right. So now we know Ollama is working, Ollama is running, and we see that we have a Qwen 0.5 model already there. Less than a second ago, we have installed it. And if we say, well, clear it out. If we say Ollama run or just Ollama and press enter, chat with the model, right arrow, and then in more we see our model that is installed. If we might have installed Qwen 3.5, which is 11 GBs, well, I downloaded it was 9.5. So I don't know if this information is incorrect or I downloaded some other quantized model. So you can use either of these. Recommended model are the first 5 choices. And yep, this is Qwen 0.4, 0.5b billion parameter model, like half a billion parameter. Half a billion parameter. If you think about it, half a billion is quite a lot. Half a billion parameters. Just to collect it, in our previous videos, we only took approx 180 lines to train a model. It was not even a 100,000. It was not even 1,000 parameters, I guess. Now it has a half a billion parameters. Think about that. So, but there are much larger models, like trillions of billions, billions and trillions of parameters are there, and they have been quantized to run on our machines properly. Okay, so we can use it any way we want. We can press / and help. Okay, I forgot /. But you see the response time, it's so blazing fast. And now I want my model to show something related to its model information. So I'll say show, and it'll show all the information. Oh, so it has available command called show info that will give our detail. Give us details about this model. So we'll say show info. And we get it. Architecture is Qwen 2. Parameters are 620 million. 620 million. That's a lot. That's a lot of parameters. Like I thought 0.5 meant like 500 million, but this is 620. Nicely done. Context length. So it has a context length of 32,768. So if you give something, some tokens bigger than this, it will probably not process it. So it's better to keep it down. Embedding length is 1024, and quantization, it's Q4 quantized. So there are Q4 quantization, Q8, and there are FP16, FP8. I don't know what is it, but we'll learn about it. Parameter stop is IM start, stop, IM end. I don't know what this is. For capabilities that it is capable of, it can complete your words. Like you type out something, tried, wrong spelling. Let's see what it does. Random string, and it would be better. Could you provide? Check the spellings and give the correct one. Okay. So spelling is also a mistake. So we'll let it go and we'll see what it does. Wrong spelling. What else? Wrong spelling again. Again wrong spelling. Let's see what it does. So now it's hallucinating. You can see it directly. So it says learn whatever that is. I made a mistake, but now it is something for this. And it's saying this is an animal that roams in a forest and savannas. What it's known for. So when it's hallucinating, it's well quite a lot. I don't know if anyone wants to read this for fun. You can just do it. It's fun. Okay. So now we know how to install Ollama. We know what Ollama does and how to pull a model and run a model. I probably was not able to run a model over here. Why? I think Jupyter doesn't allow it. That's what I think. So what we'll do now, the next step is instead of directly using, oh shit, not pull but run. So it has pulled already. Yeah, 394 megabytes. Model is nothing. Yeah. So now I am getting a prompt to send message. I am not able to. So that's what happens. Yeah, so I cannot use it. It's not usable like this. So I'll probably stop this. And what we'll do is something much more interesting. We'll create Python files that will send a request to this IP 11434 special IP address. If I open up in my browser 11434. Oh shit. Am I stupid? No. But sometimes I do. So it says Ollama is running. So this is, status. And we have many functionalities that we can do. We can either say ls. Okay, so ls is not one of them. But yeah, there are endpoints. So we know how to install a model. We know how to install the Ollama itself. Now let's move to docs so that we can see how many endpoints are there. Okay. Now this is where this much information is something that we will cover in this video, the whole Ollama documentation. And before doing this, I want to search about endpoints. So it has an API generate where we can send a message directly like this and it'll generate the message. Nice. Authentication. We don't want authentication. That is something we use, cloud models. This is how it streams. if you use curl or something like that, this is exactly how it streams. When it's not done, it will say done is false, done is false, done is false. And at the end, it will say done stop. It means, well, the response was finished. So done reason was stop and done is true. That's exactly what we get. Usages, everything like that. Okay. So these are the endpoints. All right. Over here. PS, tags, and all these things. We'll go to each of these endpoints and we'll see and discover them. Yeah. So before directly jumping to endpoints and seeing the websites of the things that Ollama provides, the API endpoints and all those, let's first of all discover everything that Ollama has to offer. All right. So again, back to help. We have seen we can use show info to get info about whatever model we are using. Okay. Architecture, Qwen 2, and all those things. Show what? Now show license. LICEN license. So we get a license as well. A long one. So it's a for some Chinese research license. All right. I thought it would be some open source license. I was so wrong. I don't know if it's open source or not, but I'm familiar with MIT, Apache, and all those things. Okay, model files. Okay, yeah, we can create model files to create our own, like a general prompt that you do in a project, and the model start behaving like this. Like you have a Llama 3 model, and you can create a model file which can, change the name of the Llama 3 to something like Tommy. And you can give it a persona of Tommy, and Tommy is like this, that he talks respectfully, he is a personal assistant, whatever, playful person. You can describe it in model file and all those things. You can create a model file for whatever you need. So this is the model file. Okay. You've read everything. If someone wants to read it more, well, you're free to do this. You're free to do so in your own time. Parameters. METRS. What it does is it shows the parameter for this model. That is model defined parameter is stop, that is IM start, stop, that is IM end. I don't know what this exactly means. Systems. Okay, let's type sys. Oh, no tab. I am so forgetful that I forget that it doesn't have an auto completion. So no system message was specified for this model, but we can specify a system message, but not from here. We are just seeing what it has to show us. Template. So this is the template. It says if system is less than IM start, that is stop, is greater than system. I don't know what this is. Not system is well in the range of this end, and is it a closure? It is what, like which language are we using right over here? And that is user. And after prompt and we get an assistant that starts. Okay, so our prompt ends, assistant starts. So this is the template. All right. I'm not very familiar with this, and it doesn't look like less than or greater than sign. It looks like a bracket. All right. Okay, interesting. So we have seen everything that it has to show. So no show. Now go back to help and let's set something. Set what? I don't know, but set session variable it says. So let's set parameters. So we can set parameters. We can set system message if we want to. We can set history so that it will save our conversation and get the context from that. We can set no history. We can set word wrap so that it wraps. How word wrap works. If you don't know, let me show you. Let's open up an NVim. All right, hi. And if I start typing like A, B, 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 whatever, now this goes on, right, in a single line. But if I say something like set wrap, this is exactly what happens. Now this is only a one line, but all the characters are shown in, without scrolling far to the right. We get everything that is there in first line directly to a face, and it depends upon the length, right? Not something we should be wondering about. No, we don't want to save it, and let's close it. Okay, and it has a format JSON, like enable JSON mode. Yep. Or we can say no format JSON, so it will not give you the JSON format. But every time in browser, when we send API request, it needs to be enabled. I guess it's automatically enabled for the JSON mode. API is designed like that. Set verbose, so shows LLM stats. This seems interesting. I also want to see the stats. So if I say hi now, okay. So this is good. This is good for comparison and all those things, like how many tokens per second has been created and everything. Nicely done. So we can do this, set verbose, so that we can get a comparison from here. Total duration it took is about 2 seconds. Load duration was about 2.12 seconds. Prompt evaluation count was 9 tokens. Evaluation duration was some milliseconds, 163. Okay, evaluation rate, like the rate at which it evaluated the prompt. Should I call it prompt processing? So it processed at 55 token per second. Evaluation count, it generated 10. I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9. So exclamation and question mark included, it generated 9. I don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I don't know what 10 tokens means. It probably, gets hidden. Not everything is being shown. I don't know, and create. I don't know how 10 tokens per second, but if it says so, we'll take it. Evaluation duration was about 532 milliseconds, and evaluation rate was about this much. So this is what verbose does. Can we set okay, so to see the stats we can say verbose. To just disable the stats we can say quiet. I don't want to show me this every time, so we'll set it to quiet. Now this is something interesting that we have stumbled upon. Now if we say hi, it'll probably not give us anything like that. Now if I say think, but this is not a thinking model, so will it start thinking or what? Let's see. Think. So it says the Qwen 0.5b does not support the thinking output. So, well, it doesn't matter if we send anything like that. It says it does not support thinking, so please disable the thinking. So we have to do set no think. I have wondering why did I write something wrong? No, THINK. Disables the thinking. Yeah, now it works. So it has set the model to no think mode. Good, amazing. So we've seen the set command, we have seen the show command. So let's get back to help. So we have covered these two. All right. Let's clear the session by typing clear as well. Now this has cleared the session. So now if I type hi again, it'll start another session by saying hi, how can I assist you? But it also said earlier the same thing. It's for, if your context is more than the model can handle, you probably should clear it. Buy to exit it, we know. Help, we know. Shut it, we know. All these 4 and these 2. So approx 6 things we have done. Now we need to see what these 2 does. So load, let's type load directly. Let's see what it does. Okay. So it says model name. Pi 3. It couldn't find the model called Phi 3. Oh, really? Ollama LS. Okay, so we have Pi latest. Phi 3 mini. Okay, okay. Phi 3 and not like this. Phi 3 MINI. Oh shit. MINI. So it's loading a model called Phi 3. So what will happen to Qwen? Will it be unloaded or will they both work at the same time? Hi. If I say hi now, hello, and it's considerably slow. So I guess that this is not a verbose. And this is not the Qwen 0.5 model because see speed difference. You'll probably see it once this hack comes up. And it's also giving us, different message every time. Okay, okay. I want show info, isn't it? To see the model info. So yeah, so we have loaded Phi 3 and when 0.5 model has been unloaded. So it's not like we have to exit this Ollama session to start a new session by saying Ollama run Phi 3 mini. We can directly just load another model and it'll probably load it just like this. Amazing. Save. So it saves your current session. I don't want to save it, but let's do it anyways. Save. Oh. So it says save and model name. Save Phi 3. So it comes handy when we create our own model, isn't it? It says created a new model called Phi 3 mini, but we already have. So we can create something like, yeah. So now if we Ollama LS, we get something called, yeah, see this? We have created the same. So it's nothing but an alias. You know how alias works? ls is a command, ls-la is a command, but I can alias to something called ll, and that will become equal to something called ls-la. Okay, so if I press something called ll, it'll act or behave as ls-la. So that's called alias, and I've created the alias. So yeah, so I show you dot bash rc. Yeah, so this is how we create an alias. Alias. That's how it works. So what happened over here is whatever the model we loaded, whatever the context it had, it just converted that into another model that we have. Now we have a Phi 3 MI. That is nothing different than Phi 3 mini, isn't it? So what I want to do now is actually delete this Phi 3 MI. So to remove a model, I think I know the command, but it's not shown over here. And yeah, this is something interesting. It says to begin a multi-line message, either open up, the dedicated notepad. In my case, new vim got opened, or just use double quotes 3 times like this. Oh shit. So now I can, copy something on terminal. We can paste it over here. What happened? Yeah, so yeah, it was multi-lined. I don't want it to process. And see, it was multi-lined. Nicely done. Let's, clear it. Control L. Paste it. Now we can see we have a multi-line prompt. Well, I'm pressing enter to send, but it's not sending, so I probably have to close it. Now it'll send it. And I don't want it to process because, LLM processing, and that too a heavy model, is not a good thing. So we'll close it. And we'll close this session. And this also. Now I know something called Ollama RM. I'm not entirely sure, but let's try. And I want to remove this 53MI that we've created right now. Oh, not over here. 53MI. Will it remove it? So it deleted something called 53MI model. Now, if I again press Ollama LS, we see that 53MI is gone. So you can create a model, load your own model, and then when you don't need it anymore, just delete it. As easy as always. So I think I've covered up the whole Ollama session, terminal session that we used. Can we do this? Help. Oh, yeah, we can use this as well. So yeah, over here we can see available command, that is to serve. It starts the Ollama. To create a model, we can use create. To show information for a model, we can directly write show. And to run a model, we have to write Ollama run. Ollama show will show it. Ollama create will create a model. Ollama serve will do the same, that it says. Ollama stop will stop a running model. Ollama pull will pull a model from registry like online cloud, whatever. It will pull that to your PC. Ollama push. So if you have created a model that is very interesting and you want it to be published, you can directly say Ollama push model, but for that you need to be signed in. So to sign in, you can use sign in, Ollama sign in, and will sign in to take you to ollama.com. You will sign it, and that's it. To sign out, exactly the same thing. Ollama list is something we have used. Ollama ls is same as saying something like list. It's the same thing, all right? Now Ollama ps is something like processes. So if there's any process that is running or any model that is running, it will show you all the processes. Right now, no model is running. So what we'll do is we'll run a model. That's what we do. And will it show me any process? So it's showing me a process that Qwen 0.5b is running. And processor it's using is CPU, that is 100%. Context it has is 4096. That's a context window. And what is this? Until 4 minutes from now. All right. Hi. Yeah, the same thing. So we know process to CP. CP is like you need to copy a model. Like you have a model called Gemma 4, and you are using, sometimes you vibe code a program. So let's say you vibe coded a chat web app where you can chat with that's not a good example. So, but let's take it anyways. We have a web app that hit an endpoint like Anthropic or OpenAI or anything. It needs an API and it needs a model name, and then it'll send the prompt. It'll give you a response. That's how API thing works. We'll see how Ollama works. But what we can do is we can actually replicate something called not the behavior, but we can just change the name. Like we have a Gemma 4 latest. If I want, I can copy this Gemma 4 latest and give it a different name. Let's say Tommy latest, and it'll actually copy the same thing as a model for us. To remove a model, we actually use this command. So not a very surprising thing. Launch actually launches the menu or an integration. So over here, let me say Ollama. Okay, spelling mistake. And this is what it does. But nowadays, we don't need to say Ollama launch. If we directly say Ollama, it'll probably launch this. Nothing much to worry about. Ollama help is directly a command which you can type, and it'll give you the same thing that we have over here. We don't want our word to, wrap like this automatically. We don't have to scroll all the way to the right. We can directly see automatically over here. That's wrapping. If you wanted to no wrap, we can say no wrap. If you want, timings for responses and tokens per second, all those things, we can say verbose, and it will become verbose. So that's exactly how we can use it. And this is the format. So we can say Ollama command, and whatever the command is, we want to, let's say Ollama RM. I want to know about RM command. So we'll say something like Ollama RM help, enter. And it gives me a, help for the remove model. So it says RM removes a model. Usages like Ollama RM and the model name, flags and anything like that. Flags for that, we have help flag, so that we can take a help, that what RM does. That's the only flag I see. Environment variable is like Ollama host. I don't know why I got this, but it's telling me the same thing that our Ollama is running at 1.434. So I think I've covered most of the basics about Ollama in terminal, right? Now what I want to do is follow along the Ollama documentations, and I don't know. Okay, let's not play with it. Is it tags or tag? I am not sure. But I've tried this. All of a sudden, it doesn't work for me. So in API reference, we'll see this, but not right now. We want documentation, and we'll get started. So Ollama documentation looks something like this, where it says get a quick start, which is the next thing that we should do. If we didn't download Ollama till yet, you can download it. After pressing this, you'll get to the download page. For Ollama cloud models, learn about them, go over here. API reference, that is this. You can press it over here or over here. Libraries that we have. So Ollama has offered up a library called Ollama. Yeah, not very surprising. So let's do that as also. I'll say pip install Ollama. Okay, control enter. And it has installed the Ollama. All right. Now we can create Python, scripts that can actually interact with Ollama. JavaScript libraries are also there for Ollama. I hope it is also named Ollama. I'm not entirely sure. But documentation is something that is, see, pip install Ollama. And these are some of the basic things. I've stuck over here, chat response. I'm not entirely sure what that is. Is it a class? It's what? I'm not sure. I've used mostly streaming response, so stream chat, and for cloud messages and all those things. Okay, so we know pip install Ollama, and we'll see that in Python scripts. We'll follow along. In JavaScript, we have npm install Ollama, and the same thing, just in a JavaScript format. Exactly the same thing. If you don't want to use npm, just a JavaScript, we can directly say Ollama browser, and it'll import the browser module. Nicely done. Okay, so let's get started. Give it a quick start. We have a community libraries that is 20 plus and all those things. Community is there. Go check it out. But we'll start from quick start. And it says, first of all, download the Ollama. Run Ollama in your terminal that we did. We can use up and down keys to navigate. We can press enter to launch. We can, use right arrow to change a model and escape to quit the Ollama entirely. Where should we use escape and where, the buy is the important distinction. Over here, we can use escape, but while, chatting with a model, we cannot press escape and just exit. Like I'm pressing escape and nothing's happening. Either I have to press Control D or buy like this. Not like this, but like this. And then escape. Or let's try pressing Control D. Control D also does the same thing. Now escape. All right. So I think that is pretty clear to us. Now assistant. So OpenClaw, well, we all know it's a AI agent that we can use, assistant. A personal AI with 100 plus skills and is very famous. First of all, it came with a name called OpenClaw. Yeah, OpenClaw, I guess. OpenClaw. Then it became OpenClaw. For coding, we can directly use Ollama launch Claude so that Ollama will be used by Claude code. We can use that for Codex. We can use that for OpenCode. Nice. API integration. This is something that we need to know. Since we have installed Ollama and it's serving already using systemd, we can directly paste this in our terminal. This is nothing but a curl command. It does what? Let me explain it to you. See, that's how I have to go to the first line in a terminal. I don't know the shortcuts for this. So HTTP, because it's not S, because it's not secure, it's running locally. Localhost 11434. This is what Ollama endpoint is. It's like, yeah, Ollama is ready. And to API chat. Okay. API chat is something, the exact API endpoint where we have to hit with a model name and a message so that we can get a response. And model is Gemma 3, but we don't have a Gemma 3. We have Gemma latest, isn't it? Let's double check it just to be sure. Ollama LS. I'm not very good with the name, so yeah. Gemma 4 latest. Okay. See, we would have made a mistake. Gemma 4 latest. I have installed it. If you have not installed it, you can directly type Qwen 0.5b and it'll work. Not a problem. And then the message. In the message, we can say the role is for the user, like we are sending, and the content is hello. And as soon as we press enter, see what happens. Now Gemma 4 is, well, a heavy model. You can see 9.6 GB. So the response will be heavy. I think I should close it before I start getting into trouble. I'll also use small model like Qwen. 0.5b. Okay, now we'll see the speed. Yeah. Did you catch it? Did you even able to catch it? See how it responds. So this is what we sent and this is what we got. So from model Qwen 0.5b created at whatever the timing is, we got a message that as an assistant, not as a user. User is something that we sent. Assistant that is sent by AI. It sent us hello, and then the another content was exclamation mark. So hello exclamation mark. Then it says, how can I help you today? And a question mark. And at the end, it says done false, which means it is not done yet. But over here, with an end character, like, yeah, it sends. So over here, it's empty. That's why we counted, 10, if you remember that, in a verbose comparison. We got 10, what is this? Tokens. So the last token is nothing, like it's literally nothing. This string is not even a space. And now it's done true. Otherwise it's done false. It's done false, done false. done false, done false, done false, done false, done false. So when it's sending or streaming the message, it says done false, done false, done false. As soon as it is completed, it says done true. And then it gives you the reason of our done. Reason is stop. Total duration it took is about this much. I don't know if it's millisecond or second. I hope this is a millisecond or some sort of microsecond. I am not entirely sure. Load duration was this much. Prompt evaluation count. So now we can count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this one, including this, 10. So evaluation count, prompt evaluation count is 10. Evaluation duration is 1753 and dash dash dash. Okay. Evaluation count is 10. We know that. Duration, this. Okay. So this is how API is sent to the endpoint and we get a response from it. Interesting, isn't it? So for the API documentation, we can directly jump to it if you want to, which is nothing but API reference and the introduction to it. So we'll see to it the next thing, but let's get familiar with Ollama first. Now it will tell us about the cloud models. Cloud models is something that you have to be signed in to Ollama, and then you can directly use the servers on the cloud that is running 120B. You can't run possibly on your local machine if you don't have a farm of one local machine. You directly cannot run this heavy model. So probably use a cloud, something like that. And there's a CLI command to use Python. You can say something like this: pip install Ollama, and well, we are very comfortable with CLI. CLI is nothing but terminal. Cloud API access. You can see to it. Generating a response. Pip install Ollama, and then make a response to the cloud. But you have to send API because you might have gotten it from Ollama. But this is something that is not we require. We want to run it locally, so local only. Disabling Ollama cloud features is best. Now streaming. So streaming is something that we already saw. So this was actually streaming, but we want to stream just this character. So we have to go into messages, isn't it? We directly have to go into messages, and from there we have to get into content, and whatever the content is, we have to print that. Remember this format because that's exactly what we are going to do in Python script, and you might be confused. What are we doing this? Why are we doing this? But if I create a JSON file, let's cat it to response.json. Oh, wrong spelling. Response. And if I open up the JSON file in any proper medium, let's use Brave for now. That is a browser. Oh, give me the option. Where did I save it? Add response.json, isn't it? If I say ls, okay. Why this? Curly brackets, I am not entirely sure. Let's use new vim. Okay. This shouldn't have happened. So let's move response.json as ls. Okay, so this is a logo, not actually in the name. Okay. Open it up in a browser, something. Yeah, so we have opened up in browser, and if we say pretty print, oh, pretty printed, damn it, Let's do it. Why isn't it pretty printing? That's stupid browser. And this one is the same, but still. Did we not just copy this link? I don't know. Sometimes it does something unexpected. If I pretty print it, why is it not pretty printing? I'm not entirely sure. I guess because the JSON file might not be. Set wrap so that we can at least understand what's happening. Mhm. Done is true. After that, we have some more. But over here, it's a little bit colorful, so I guess it will be helpful. So first of all, we have information about model, like at which time it gave the response. All right, exact seconds or something like that. And then in message, like this is something that is not our use for our use, but this is something interesting. We can get into message and then content, and we can see the content. And this content has space and I. Space and I is considered one token. Space and can is considered another token. Space and how is considered one token. And this bang or exclamation mark is considered one token. Question mark itself is considered one token. And this empty one is also considered one token. So if we count it, it's total of 10 tokens. Okay. I don't know why it didn't pretty printed. All right. Now, since we just used curl and this API, we can use the same thing in Python as well, and everything will remain the same. So let's go to the Ollama and use Python. We've already installed, the Ollama library. Nothing to worry about. Now it says from Ollama import chat, and then we are saying chat and model is not Qwen 3 but 0.5b, like this or not? Yeah, like this. Message is, what is this number, isn't it? Stream is true and in thinking is false. So stream true does what? Well, you'll see it. It'll start streaming like one by one, character one by one. I hope to say it. I'm not entirely sure. So yeah. Okay. So this is streaming, one message at a time. This is called streaming. And it was not a thinking model, so it didn't think probably. So not to worry about. We'll do the same. And now we'll start creating 1.py. I name it like this only because naming is not my forte. And this created an error because role is a string. And if we pass it like this, it'll probably give us an error every time. So new message cannot be written like this. It has to be like a string. Okay. Thinking also. Append the accumulated field to the message for the next request. Thinking, and the content is content. So that is the variable over here. Thinking is thinking, the message, a variable over here. And we can append the content from here to something like, okay, what's 1 times 0? Okay. Will it work? So if I run it directly like this, it'll probably not work. And you might know the reason. Yeah, so it says no model named Ollama is found. So to do that, we have to, first of all, create a virtual environment. Little bit of time is taken. Yep. And then activate it by this command. It's activated. And we can now use pip install install Ollama like this. But I prefer to create a requirements.txt. So we'll create requirements.txt. Requirements.txt. And I know that we'll need Ollama, but I also know we'll need requests. So I'll install both of these. Okay. Now we can say, okay, pip install -r, and from requirements.txt, install everything. Yeah, so if we see pip list, we'll see that our Ollama is there, and it has also installed some other dependencies. And request is also there. Request is used to, data endpoint, link, whatever. Okay, so now if I try running my Python file that we had, Python, what is it, 1.py. Yeah. So what is it? It gave us 942. And what is 942? Let me check what I actually did. Okay, so Qwen 0.5 model, I don't want to use this. Let's do Ollama ls. Ollama ls. At least use some decent models. Set decent models like we can use Qwen 3.5, not bad. Mistral, so let's use Mistral latest. I've not tested it yet. I have not tested it yet, so latest. And let's see. We can see our process is running because we can say Ollama PS and it shows, oh, the product of, and this is called streaming. All right. It's not processing everything and sending the whole response at just once. It's processing one word at a time. And as soon as the word comes, we are seeing the word over here. This is called streaming. So we got 17 times 23 is 391. Let's cross verify it. 17 times 23 is 391. Nicely done. What about our second response? Was it sent? What happened to this? I don't know. I'm not entirely sure. Even if it might be sent, there's nothing to, stream it like this. So if we say stream false, let's do it. Now what happens is it's actually doing the same thing, creating one word at a time. But now it's not a chunk message. So okay, what we'll do is we'll go to here. We'll say create a basic Py script that uses requests to 11434 with a prompt and give us a response. No thinking right now. We'll just see this much. So we'll try to keep it as simple as possible. What we are doing is we have a request. We have a JSON so that we can process the JSON that we'll be receiving. We have a URL, or we can say base URL, and the model is Gemma 2B. We have Gemma 2B. Okay, we have Gemma 2B, and it's fairly decent model, fast also. Stream is false. Get full response at once. That's what exactly happens. And we are trying. Well, just to be safe, trying is a brave thing. But we can also just say response is equals to request.post URL and JSON is payload, JSON or application, like that. And if response status code is 200, like everything is okay, then send the response JSON to variable called data. We are assigning it, and we are printing the whole reason response like this. Whatever the response is, exactly like this. Else, if we got another status code, we can just say error and whatever the status code is and response text is. Exception can occur, that is exception as exception occurred, and whatever the exception is. So let's run it. Now this is stream is equals to false. That's why we are not seeing any stream at all. So I like stream is equals to true because it feels like AI is working for you. Right now you don't feel anything, even if it's working at the background, but you don't feel it. That's not something I like. See, even earlier it took this much time, or nearly about this much time, but now we feel the time. Why? Well, still no response. Okay, it's prompted to create something very simple. Just to understand, this is the bare bones behind it. This is exactly how it works. All right. And when the streaming is false, when the streaming is true, we have to go inside message and then response, and whatever the response is, we take it and we feed it at once for a loop. Okay, in a loop. But this is the bare bones. We, you know, send message to this API generate. So we have two endpoints, API chat and API generate, but we use API generate over here. Sometimes we use API chat. I'm not sure, but we'll read the docs and we'll know about it. That's something that we must note. API generate and API chat. These are two endpoints provided by Ollama. Model, we have to define it inside a JSON structure. That is, model is to be prompt, whatever the prompt is, stream, whatever the stream is, and so on. So yeah, in one single shot, we get the whole response. All right. If we create stream is equals to true and use a very dumb model, Gemma 2B gave us a lot of response. We don't want it. We want 0.5b of Qwen. Okay. Why? It's a stupid as well as fast model. Qwen. Qwen. And instead of streaming is false, we'll create true, that we can compare between these two. And it's streaming in backend, but we are not seeing the result. Why that can be? Well, we first of all got a exception because we were not handling streaming enough. So in this, we cannot do stream is true. And in the previous one, in the 1.py, we cannot do stream is false because they are not handling that stuff. Okay. So while the stream is, true, it means we are getting the message, and whatever the thinking part is, we'll get, if it's thinking. If it's not, we'll get the message.content, and whatever the content is, we'll get that. And we are printing that. So let it work as it is. Python 2.py. It will not stream at all. Yeah. Python 1.py. You tell me which one do you like? Oh, what happened to 1.py? What happened to the 1.py? Shit. Did I do something? Yeah. So I think it's using a better model. That's why it's slowing down. What? Okay, so it's using Mistral latest. Or use Gemma 2B. And that's when it's not even thinking. Okay, so Gemma 2B, I guess, is a thinking model. No, it's not a thinking model. So, okay, so we directly get a response. But let's choose a thinking model like Gemma 4, Gemma latest, all right? LATEST. Okay. CW, Gemma latest. Oh, Gemma 4 latest. Sorry. Gemma 4 latest. People can do errors. And now this is a heavy model. So you see how it's thinking. This is not its response. This is the thinking process. And the response will get a different sort of format. So Gemma 4 is very special because it's a text as well as a vision model. So it can take images as well, and it thinks. That's the exciting part. Okay, so, well, should I let it run? Okay, I'll let it run for now. So the answer we would have gotten would be this, right? And a format for MD. But thinking models are great at the thinking process behind it. That's what makes them great. So I like this. I like it absolutely. Now you might be wondering why it's so slow. Well, it's because we are using API endpoints. I don't know whether they have optimized Ollama for it or what, but somehow Ollama doesn't feel that slow when we are using, terminal Ollama. I'll be using the same model, that is Gemma 4 latest. Okay, just to be sure there is no Gemma 4 latest. Like latest is not getting shown. E4B and latest are the same model. Like when I installed it, I did not need to install anything. It just got copied, I guess, with the same name. And now if I say, what's 17 times like 29? So this somehow feels faster than when we were using Python to do the same. I don't know if it is because Python's overhead or, this Ollama has optimized it to run well when just using Ollama. API endpoint somehow has a latency when even running locally. And I'm not entirely sure why. The reason I can think of is Python overhead, that is, loop and all. It takes a long time to run, so it's not processing as much as it should. And second thing I can think of is, well, they have uh, optimized their own Ollama, program to such an extent that it feels so jiffy fast. So you're using the same model, same question, or almost the same question, but see the difference between the speed. Uh, Yeah. So we got a response and it suddenly felt really fast. So I was going to cut it, but now the earlier one, I'll not cut it, not even fast, not even change the speed. So that you can compare which felt nicer. Well, this already feels nicer to me. That's what I hope. So we can use Python programs, but as we see, it's not, well, somehow it doesn't feel that interactive. So we know what streaming is. Streaming is this thing, like the message, the each token, as soon as they were processed, they were shown to us so that we were engaged. That's because of streaming is true. And for thinking models, we can make the thinking false so that it will not think. We can make it true, and we have to do that over here. So think is a parameter we can use. We'll see that in thinking. All right. Let's go to next. So thinking is a parameter. So these models supports thinking. Like Qwen 3, I don't see Gemma, but Gemma is also there. So we can make the think parameter, like stream parameter is there. We can include the think parameter and we can say true or false. And that will change the whole damn thing. And whether it thinks or it doesn't think. But for GPT OSS, we cannot do that. We can either use low, medium, or high to tune the trace length. And message.thinking is the chat endpoint for the thinking. Why? Well, if we have a curl, we can show it, but let's not do it right now. But as we got message.content, we will get something like message.thinking because it's thinking. All of a sudden, both are the token generation, but thinking is something that models use for their own reference. But they also show you that they are thinking for a long time, but also interactively so that you don't get bored. What? And message.content is for the response that holds the final answer. So yeah, it has given us the curl that we can use. And we have a Qwen 3. Do we have a Qwen 3? I don't know. We have a Qwen 4, isn't it? I can never be entirely sure. So let's use, where's the Qwen 4? Qwen 3.5 latest. Okay. So let's change that to 3.5 latest. Right. I'll see what it does. It has various parameters like messages. Think is true, so it'll think. Stream is false. Okay, so it'll not stream probably. But since this is a curl, we'll get a JSON. Let's see. But streaming is false, so we'll probably not get a JSON. We'll directly get a response. But it's thinking. Let's see what it does. Since streaming is not true, I feel so damn bored. So I'll probably cut it or change the speed. So it has given us the response. So it looks a little bit different, but still it's JSON. So if we copy it and try doing the same thing, append it to, not append, but write it to response.json and try opening it up, response JSON, and pretty printed. Even it was not able to pretty printed. But see, it was thinking a lot. The thinking process was there. But since we were not even streaming, the streaming was false. That's why I hate streaming is false. But then what it does is it gives you the whole damn thing at once. All right. So this, every thinking and response, everything came all at once. So if you have a powerful computer, well, you can always use stream is equals to false so that you don't have to go to the JSON message.content and process that. So that, yeah, if you have a GPU, your model is running quite fast. You can use stream is false. And then you don't have to, traverse through the whole JSON structure to get your, tokens out just to print it. So it can be beneficial for certain cases, but I don't think it's very good in my case because I need some sort of interactivity. That's what I expect. So I see some thinking processes that it did. Uh, backslash n is for pressing enter in our notepad, giving us new line characters, but it's 2 times. And then the first point was to analyze the request. The user is asking for the count of letter R in the word and strawberry. All right. Now 2n, which means enters 2 times. And the second point was analyze the target word and so on, so on, so on. And it's taking the word apart. It's thinking about it. It has thought about it and said it's counting one by one. So count is 1, then count becomes 2, and count becomes 3, and then it's verifying. So that's what thinking does to the model. It starts actually thinking everything up. But it's just like a token, generation, but for thinking process, and that takes time. So it will be better to just show everything while it's thinking. So let's do it. Let's say true. Now let's see. It'll still take time, but we'll get something. So see, we are seeing the thinking model. So now we have to go into message, content, but content is empty. So we don't have to traverse into message content. We have to traverse into message dot thinking. And in thinking, it's actually thinking. The user is asking for the count of, and so on. Now this is very interactive if you think about it. It's thinking. And if you want this sort of response in a JSON format so that you can traverse to message.thinking and get this string out, you can do that. It's your choice. If you don't want to do something like this, well, probably don't. You see how long it is. Sometimes it's amazing for the interactivity and all. Sometimes no, nobody cares. Okay, so I'll close it. So now we know what streaming and thinking does. Streaming just keeps the user interacted with while the Llama or any other model, Qwen, whatever large model is running on your PC, and it takes time. So if I had a powerful PC, it would take this much of a time. And all right, I am taking in general PC, and this much of a time you have to spend. Now over here we have a Python script in which thinking is true, streaming is true, and we are traversing the same thing. We actually ran this script earlier as well, isn't it? The first script that we ran was this only, 17 times 23. If you want, I'll let it run in. I guess this was the, yeah, so this was the same damn thing. Qwen 3 is there. So will it be able to fetch the Qwen 3 model? It says no model Qwen 3 found. So can we get a Qwen 3 model? Because it's heavy model, I know. So will Ollama be able to get this model? Ollama, not run, but pull, because the run doesn't work for this. It actually hangs up Qwen 3. And after that, I want Ollama to, open it now, sorry, list all the models available. Well, while downloading in a terminal, it still makes you interactive by showing how much percentage and all. But over here, I don't think it works like that. You can use terminal directly, but then it won't persist at all. That's why I'm using the Jupyter file, so that it can at least save what we are doing. Okay, till it's doing that, uh, let's get back and see what it does. So CLI quick reference. So we can run something like Ollama run and whatever the model name is, and we can say think and where should I visit in Lisbon. So, well, if you think about it, this is a new format to get a response. So if we say Ollama run and Qwen, just for quick response from them, Qwen v, and let's say hi to it. Exactly the same. Since Qwen can't think, so we cannot use a flag called think. We'll do that, but it'll probably give us an error. And this is for single run. It'll not see. We have the terminal back. So if I say think as a flag, it should probably give us an error because Qwen 0.5 is not a thinking model. Okay. If I say, well, 4 and latest, and it'll respond, oh, what happened? Oh, my LS. Shit. Am I that bad? We have Qwen. Where is Qwen? Qwen 3.5. Shit. Gemma 4 or Gemma 4 is there. Gemma 4 latest, but Qwen 3.5 latest. All right. So Qwen, not 4, but 3.5. All right. Think about it. It'll think, and we are getting something at least interactive loading, and it's thinking like it should. And it's not using our Python, nothing. It's just using Ollama, the program, and I think it's very optimized. So we immediately start getting the response, and that's good. Is it done? Yeah, so it actually fetched Qwen 3 latest, and let's name it properly, Qwen 3 latest. Let's run it. So we get an error saying what? Okay, so that's why I didn't use, better models. It says model requirements is 5.5 GB, but available is 1.9 GB. Status code 500. This is something that has been happening in like Colab only. So I have a RAM of about 12 GB available, but I cannot use it to run local models that are not actually stupid. So I think this is some sort of restriction. I was not able to debug it. So probably we'll not use Qwen 3. And Qwen 0.5b cannot think. So yeah, we are stuck. We should have purchased some sort of VPS, but that takes money. If I let it run, it'll probably fail because Qwen cannot think. It says does not support thinking status. These sort of errors, we are very now getting familiar with it. Now since it's not thinking, will we get something? So we got 956. Such a stupid response. Such a stupid response is this. Okay. Let's accept it. That's what we get. And let's remove this block since it'll probably have no use. All right. So we know about thinking. We know how to run in just one single line. Ollama run, whatever the model name is. If it can think, you can use a flag think. If you want no think, can we declare no think? And no think. So there is no flag called no think. Okay. Yeah. See how jiffy fast it is. If I don't use flag called think, will it give us the response quite faster or just added space? It should give us a response directly. Oh, damn. Even without a thinking flag, it starts thinking. That's not good. That's not good at all. That's why I don't love Llama 3, but it's something that I like using because it does not think for that much. Thinking also takes up, the token and the processing and all. It's the same as token generation, but instead of generating token directly for the user, you're generating so that our AI model can understand the context of what we are actually asking by breaking down everything. That's what thinking is there for. Disable thinking by saying thinking, oh, think is equals to false. We can do that. Let me do it. Otherwise, think is false. FALSE, exactly. And summarize this article. Well, I just want to say hi. A very simple respond. Respond very simply. Yeah, so it said hi. This is something I never expected. So I like this. I like this thing called think is equals to false. And we directly got a response for hi. Otherwise, just for hi, it starts thinking. That's not something good. Now we know. Okay, so we can let it think, but we can hide the thinking process behind it. But what's the point of it? I don't want to because it takes time and so on. So on. Like there are multiple reasons, and I've shown you multiple as well. Set think and set no think is something that we are very familiar with because we have dissected the whole Ollama program that was there in a terminal. So we can say Ollama. Inside that we can say set no think, and it will probably start not thinking. But for GPT OSs, think cannot be set to no, so we can either make it low, medium, or high. All right. So we are very familiar with now thinking. Now structured outputs. So now structured outputs lets us enforce a JSON schema that is there. If you want something in a format, like you want to make a presentation. So I made few apps in which this presentation making app was one. And that was the first one where I actually integrated an AI. So let's say you want to create a presentation and you want the output in a format such that you get the slide one, and inside that you get the title and the content. So that sort of schema. You can enforce it by a structured output. So now this is a normal curl, I think. Yeah, we have a role, we have a content, nothing specific. Stream is false. Okay, so format is JSON. So let's see what it gives us. We don't have GPT OSS. What we can do is not use it. Yeah, so we got a response, we get a message, and whatever this is important. That was model, this is a message. In message, we see content and we get a line saying that location is North America, size is 963, I don't know, kilometer, meter, centimeter. What is the size? Population is 38 million, billion, trillion. What is it? Okay, I can't expect something more from a 2 billion parameter model, but all right, this is a good response. And the format I will set in one line, so it does not abide by this. It just takes it as a prompt. What it abides by is this thing called JSON. So we asked it in a JSON format and it actually gave us in a JSON format. So starting from here, no, ending from here, starting from here. This whole thing is a JSON. All right. Everything is a comma and I like it. It's nice. Now generating structured JSON with a schema. So we now define a schema over here, type object, and name has a type string, capital has a type string, language has two things, type first of all array, like how many languages are there, and then items, and then again string, and required is name, capital, and language. We'll use a better model like, since I cannot do that in Colab because we cannot use better model over there. Better model, we'll probably use the Gemma 4 latest. Yeah, Gemma 4. latest. So we got a response from Gemma 4 saying, content is this, and it's on JSON. See, name, we have a Canada, capital, Ottawa, language, English, French, indigenous languages, etc. So, multiple languages. And then thinking. Why is it thinking? So here's the thinking process. Okay, so thinking must be something. Did we say thinking somewhere? No, so why is it thinking? I'm not entirely sure why it started thinking. So thinking, here is the thinking process that leads to the suggested response. Analyze the request. The user asks, simply tell me about Canada. And this is extremely broad, open-ended request to be helpful. The response must be comprehensive, well organized, and allow the users to drill it. Okay, so it's a long response, but the first, JavaScript, sorry, the first JSON file was something that we required, and exactly what we got: name, capital, and languages, and that's what you got in the first line. And so the thinking process, well, we never specify that we want it or not, but it gave us anyways. Not something we really like. All right, doesn't matter. Now, if you might be thinking, who writes this much of a, curl command? So you're absolutely right. So what we can do is, let's copy a short curl command and let's make a directory for it called curl. And inside that, let's do what? To run any, bash command, bash script, what we do is we create bash files. So let's say 1.sh. I'm very lazy with my naming, so don't mind me. And now we can freely edit it. Instead of editing it in only the terminal, we can edit it to, let's say, Gemma 2B model. And to run it, we have to make it, first of all, executable. Like if you say ls, and you'll see it's only readable, not writable. Write permission is given to just the users, the main user. Rest of them don't have any X. So note, when I make it executable, note the changes. So to make it executable, you have to write chmod. So modify, the permissions, and then we'll add plus. Plus means we'll add a permission, and X is for executable. We'll add a permission to execute what? A file called 1.sh. And as soon as we press enter, it has been changed. And see the difference. First of all, the color changed because now it's executable, it's green. And we got X everywhere. See that? Yeah. Now we can, to run it, you just define that the path of the executable file, like it is in this directory. That's why I used this thing. This means that we are in the same directory, whereas 2 dots and / means we are in the back directory. Okay, so this is how we run it, and it'll run it and will probably give you a response. Oh, I should have edited it a bit more. To stream is equals to true. I really want it to be streaming instead of just staying shut up. Just staying quiet is more dramatic. Yeah, so your streams. So we can always create sh files, which is bash files, to do what we exactly wanted to do. Nothing stopping us from that. So all these curl commands, we can just copy them. We can create 2.sh. We can paste it. We can edit it however we want. The thing we want to edit mostly is, well, the module's name, Gemma 2B, and that's it. Oh shit, I am using Vim, sorry, new Vim, so that happens sometimes. All right. So we've seen all of these, response from these curl commands. Now let's use Python now. So this is, example to extract structures data. Exactly the same. Over here, we got structured data called name, capital, and languages. And over here, what we'll get, we are creating first of all pet, and base model is something that we get, and Python tick. We are using that. We are saying that we have, 4 or 5 parameters called name, animal, age, colors, favorite toys, and their type, whether it's a string, it's an integer, and whatever. Then we are creating another class that's pet list, and it is also taking the base model, and it is taking the structure from the class pet, and it's creating a list out of it. And then we have multiple pets, I guess. And then we are passing that to a smart model, not a dumb model. So we'll pass it to Gemma 4 latest, because GPT OSS is out of our reach now to run it locally. And yeah, we'll send, I have 2 gets called named Luna and Loki, and we'll try to process it, and we'll print the whole pet after we get the response dot message dot content. So from the response, we are searching for message, and from message, we are searching for content, exactly how we usually get. This is the whole response as in variable. From that variable, we are traversing to the message. From that, we are to the content, and we are taking whatever the content is there, and we are printing it. So this is the benefit of using Python. Everything is much more clear. Now we'll create 3.py since we already have 1 and 2.py. We'll paste it. We'll run it. Oh shit. There's one mistake. That is, we've created 3.py now, and there's a mistake in 3.py. That is, well, anyone? Yep. Our model. We don't have GPT OSS. Gemma for latest. Okay. Let's run it now. Python 3.py. Run it. So we got a response here as well. So pet is our pet name, Luna, cat, age 3, silver, favorite toy. So it has, created 2 pets and in the format that we wanted and everything. Okay. Because I don't know, Luna and Loki both. I don't know why I did that. And Luna and Loki. What's the difference? And Luna Loki duo. Right, so I think it's hallucinating as well. So not a big deal. Model like this, well, hallucinates sometimes. Sometimes they overthink stuff. Not a big deal. But yeah, we got what we wanted. So yeah, something like class can be used to specify the format of the response you are expecting from a large language model. Specifically our special offline large language model, that is Gemma 4, Qwen 3.5, whatever. Now vision with structured output. So we are also using image, I guess. Okay. So we are also passing an image. So to pass an image, what we have to do in messages, till yet we have sent only role and context. But as soon as we want to send an image to a vision model like Gemma 4, we can use images and path to image.jpg and exactly like this. So we'll create a Python file, 4.py, and along with the Python file, let me show you another thing. I think I have image at the back folder. The back file. Let's go back a little bit more. Let me give you an image. All right. Let me give you an image. So to get you an image, you have to go in vision model. Let's download an image. And this will be, there in GitHub. So no need to worry about it. So we've downloaded an image. Open what? Open something called test.jpg. So this is our image name. And the directory is like the present directory where the fourth is fourth.py is created. So we have to change the path to image to something called test.jpg. And since it's in a present directory, so we'll say something like this. Okay. Gemma 3. No. Replace it with 4 and append it with, well, latest. Exactly. So now we have an object with name, confidence, and attributes. Image description gives a summary, objects, scene, colors, time of day, setting, text content, anything. All right. And if we save it and run it, it will take first of all time. .py. So now to give you an example of what we are doing over here in structured output, that must have been the last one. So yeah, this was the last output. We'll see the output from, what we got over here. Okay. But till then, let me give you an overview of how image and vision works. So when you go to the, take me to ollama.com. All right. Now over here, you see you have a tools that will give you, text model. So everyone has a tool. Yeah, this has a vision. So Gemma 4 has a vision also. So we can use it, to process some sort of images that we can send it directly. Neurotron, it has tools, thinking. Minimax has tool, thinking, and their cloud model. So, well, Qwen 3.5 also has a vision. Interesting. All right. This is also what I also heard. But there are also dedicated image models with name sort of LLaVA, isn't it? LLaVA. I've also installed it. So not Llama, but LLaVA. And that's a image model. So we'll say vision. Oh, we've specified tools, no? That's why it was not showing. So yeah, there is it. LLaVA. I don't know why this looks like this. But if we open up a terminal and let me show you. Oh, sure. Llama ls. So we have a LLaVA 7 billion parameter model and we can run it probably. It is 4.7 GB and it only processes the image. So let's go to a directory. Not do that. Just take a terminal. Yeah, directly in the directory. VLS, we have an image called, where is the image? Yeah, test.gpd. Now let's Ollama run and LLaVA 7B. It's taking time, Will, because Gemma 4 is working and it almost takes 10 GB. So yeah, I don't think I can use it right now, but I'll show you. After this, processes properly. Let's wait. So we got a response. That is summary. This is a close-up photograph of orange tabby cat looking directly at the camera. And the cat has a bright, attentive eyes and prominent whiskers. The background is somewhat blurred and showing a light colored, possibly concrete or paved surface with a distinct red line. So, like, I know how the image looks, but let me open it for you so that you can compare the description. So, this is the cat, okay? And let's open up description over here. So now see this cat, see the description. So this is a close-up photograph of an orange tabby cat. Yeah, directly looking at the camera. Exactly. The cat has a bright, attentive eyes. All cat has. Prominent whiskers. Oh, yeah, it's visible. The background is somewhat blurred. Exactly. Showing a light colored. Yeah, it's light colored. And possibly a concrete or paved surface. Exactly. It looks like a road or something like that. So paved surface with a distinct red lines running horizontally across it. Yeah, we see two red lines. Exactly. Now object name is cat. Confidence 0.98. Attribute orange tabby. Looking at camera and attentive. So these are attributes, three attributes. Now second object, that is background. Confidence, like how much confidence does this model has that it is a, whatever it's describing it as. So it has 0.95% confidence, I guess. 1 is max, 0 is least. That's what I think. Attributes are light colored, blurred, outdoor setting. And the third object, that is red line, and it has a confidence of 0.85. Like it can be red ropes and thing, but it sees as a red lines and two red lines possibly. Attribute is horizontal, linear possibly, painted on the ground, but it's not painted. Something that is painted does not have the distinct, height to it. So that's why its confidence is somewhat low. And the screen is outdoor setting. Colors that are found in this image is orange, brown, yellow, red, and beige. Time of the day is night. Now see, you're seeing something. Is this night? If you are outdoor, if you're seeing the pavement quite brightly, it's definitely not night. So I don't think this is night. Setting is outdoor. Text context is, well, none. So not everything is correct. Like time of day is not night exactly. But yeah, what can you expect from a model that is 4.4 GB? But it can actually describe this. This is quite amazing. You cannot only use it by using Python. You can say Ollama. Yeah, so I was gonna show you the same thing. So you can run it like this. Let me show you over here. Why is it taking so much time to load it? I think unloading the previous model, loading this one, it's taking toll on it. Let me see. Ollama PS. Yeah, now the previous model is unloaded. Okay, context is 4096. Note that because we can change it. Now we can send a message. What is in the image? And to send an image, how do you send it? Where? The path. Like this is in a present directory, and it knows we are in the present directory. And we send the whole name properly. We cannot autocomplete it using tab. So be sure that your image is exactly named as you are passing it, because that's where you can make a mistake. Make sure the domain, sorry, why am I saying a domain? Make sure that the extension that you're typing is exactly the same and matching the image. It can be JPG, it can be PNG, it can be JPEG. I've never faced some sort of issue. So yeah, this message is added image text.jpg is sent to you by Ollama. If it does not attaches the image, it does not send you this message. So this is something Ollama does for you. It attaches the image, it takes it in base 64 encoding, encodes the image and gives the encoding to LLaVA to process what's happening. So all that is done by Ollama. And then LLaVA model is there that just process whatever it gets as an input. So let's wait and see. So now we are getting the response. The image shows a cat. It's a Well, close up, whatever. Let's see. So it has fully responded. The image shows a cat. It is a close-up photo, and the cat appears to be looking slightly away from the camera. Well, not sure. It was looking directly at the camera, and the same model, well, said that it was looking exactly at the camera. And now it says it was looking away from the camera. Towards its right, with a curious, attentive. Let's open it up. Image again, and I don't see. It's not looking directly at the camera. It's directly looking at the camera. See the pupils? Yeah. So it's definitely a close-up. The cat appears to be looking slightly away from the camera. Not true. Towards its right, with a curious and attentive expression. Well, cats are like that. Cat has an orange coat. Well, we can say it has a coat. Yeah, if that's the word you want to use. Which suggests it might be a mixed breed or specifically a ginger or a tabby cat. Okay. So I think it's doing a fair assessment of what we have right now. Uh, Somewhere it's not that accurate, but does it matter? Not absolutely not. So now we know, and lava 7 billion parameter model. Oh, we got it. And then we don't. What is happening right now? Yeah, so this is the lava model. It's a vision model. We can run it like this. We can use CURL as well. Okay. I thought we could use CURL in Python and JavaScript directly to install the model lava. It was just to run it. If you don't have that model, it'll probably say doesn't have the model. Now it says, write the path directly, either the full path or a relative path, depends. Or the best thing you can do is directly like the write the base 64. So this is a base 64. So if I copy this, let's see what is in this picture. Oh, what happened right now? What happened? Oh shit. Control Shift C is shortcut to copy from terminal, but in browser it's just Control C. That's where I sometimes get confused. Error lava not found. Lava, why is it not found? So instead of doing something like this, it's very stupid. Why not just make it a sh bash program and run it like that? So we'll do that. Not 2, but 3.sh. You already have 2. We'll paste it. And over here, we'll say lava is not there. So what? We have lava 7 billion parameter model. And now chmod it, chmod plus x and 3.sh. Now let's run the 3.sh and give it time. And it will probably describe what this image is. So what is this? This is a base 64 encoded image. This is exactly how it looks. This is what image is, directly or indirectly. Everything is a binary, so you already know about that. So let's wait and see. Yeah, so it has responded and it was streaming, which is not very good for us, but still we can understand. So the response is the image shows a cute Cute what? Cute comma anthropomorphic. Anthropomorphic. What is it? Anthropomorphic character that looks like a small pig, uh, and it appears to be waving. See, W is one token and aving is another token. So tokenization is different, but it's better than just taking characters. So otherwise, it would think about that. It would just spawn every character in a time. Character, 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 space, character, character. Different, but we'll make it when we'll make our model from base up. Then we'll use character wise. All right, that's in future. Waving with one hand while its other paw is raised up as if it. Okay. So we don't know actually what the image looks like. So I'll say, we have a base encoded image stored in a variable create the image output dot jpg. So let's get a script from here, and we'll paste the base 64 string, and this is it. This exactly is it. And what I'll do is I'll just create it over here with the name of convert base 64 to what? JPG, PNG, JPG to JPG, and then we'll paste it. And over here we need to paste something interesting. Oh shit, I made a big mistake. That is to not even name it properly. Not why. It's important, no? Yeah. Now it's there. Let's env into the 3.sh. Let's copy this variable and let's paste it over here. Clear out everything else. At the end, clear out this. Go to home. DD. Paste it above. Go to the end. Delete. Let's save it. Now let's run it. ls, and we have a output.jpg. Okay, to run it we have to run open and output.jpg. Yep, so this was the image. Yeah, that's it. This was the image it was describing. Nicely done. I would say nicely done. Yeah, exactly. All right. So now we have seen streaming, we have seen thinking, we have seen structured output, we have seen vision. Yeah, we have actually covered the vision. All right, we have covered the vision properly. Isn't it? We ran it exactly like this. Instead of in one line, we ran it usually like we do. But all right, doesn't matter. Now this is something we can do using Python. Okay, we'll just copy it. We'll go back. What did I do? We'll just, oh, what happened? No. Yeah, so we'll go back. And over here, we'll create 5.py. We'll paste it. We know how it goes, isn't it? Let's use Gemma 4 and latest, because that's also a vision model, isn't it? Even Qwen 3.5 latest is our vision model. Now image path. So whenever we pass image, it must be in a list. All right. So we can directly pass the path, what are the images, and we'll say the path is this. Instead of taking the input directly from the user, let's give it a path that it is test.jpg. All right. Now this path variable will come up over here, and this is a list which stores strings. So we can send even two images at the same time, and it will have to respond. Now we have two things. We can either send the path directly as to the image, or we can read bytes from it and then send it to. We can either encode and decode it from base 64. Everything we can do it. All right. To run it, just Python 5.py, run it. I'll see you in few minutes. So it gave us a response that it is a close-up photo of an orange tabby cat. Like exactly what it was. And see, there's no stream, there's no thinking. We can enable them, but we shouldn't, right? It'll take time. Anyways. Now, if you want, instead of directly sending path, we can send them as base encoded image. And let's change it to img, isn't it? Because path is going directly to image, and image is taking base 64, and it's encoding the path after reading the bytes, decode bytes. All right. I'm not an expert, but I know this would work. Okay. It says base 64 is not defined. Did you forget to import base 64? So I did not forget, but Ollama itself did forget. So I'll probably, if it's open source, I'll edit this docs, or someone like from your side can do that. Base 64. Just this single line caused the error. Now it will not. Yeah. So this is also a close-up photo of an orange tabby cat. I don't know whether it was cached or something like that, but this response seemed quite faster than the earlier one. I'm not sure why. Okay, and let's do another thing. Since we have only one image, that is test.jpg, let's give it another image as well. So yeah, let's do that. We got a response, a ginger or orange cat. Like, so short. I like responses from Gemma. Even if it's not a dedicated one, but still, I like it. And let's create another variable called path and one, and we'll give it a path that is from here. We need to get into curl, and over here we have a jpg that is output.jpg, the Ollama thing. And we'll say this is image one. What this will be, it's nothing, the same thing like this. Instead of sending one image, after comma we can say image one. Not much of a problem. Now, what happens is this takes the either, we can process it like, either way, or we cannot even process it. We can directly send it. Doesn't matter. Llama does it for you. Uh, what is important is this path. So we can either directly, take these two strings and without any variable, just put it over here with a comma in between, and it'll probably work. And for multi images as well, but it'll take more time. So let's run it and see how much time it takes. So it gave us a response that we have a picture of orange cat outdoors with a red object in the background. That's not what I expected. All right. So now instead of passing it as path one, path two, and processing it, what we'll do is we'll do nothing of this sort. All right. I'm just well commenting it, because if you'll get it, just uncomment it and just change this line. So we'll send path directly over here, but as a string. All right. s.jpg, first one, then comma, second image, curled and orange. Now let's change the content as well. So what is in the image? Let's send it. There are two images. What is in the image? A very short prompt, but still. Okay. I noticed that, well, as always, my spelling mistakes. So it says, well, we got an image one and image two. So based on two images provided, here is a description of what is in each one. So image one was the cat and the second one was the Ollama's logo. Let's open it up. Output.jpg. Yeah. So this was one image. Oh shit. And let's open up another one. Another one. Yeah. Sorry for the lame jokes. I'm truly sure. This was the second image. All right. And what we got is, oh, and what we got over here is image one, the top photo, like this one. So it says this is a photograph of a ginger or orange tabby cat. The cat is looking directly at the camera. So yeah, it recognizes that cat is directly looking at the camera and appears to be outdoors. The background is slightly blurred, like bokeh effect, exactly, and features a prominent red line or a railing. Probably railing. Railing is a better answer. Image two, that is the bottom drawing, which this one. Now this is a simple black outline cartoon or emoji drawing of a cute fluffy pet-like creature. Yep. It's probably some sheep or something. And possibly a dog or a generic cartoon. Well, it's a sheep and you can't recognize it because sometimes it looks like a camel, sometimes it looks like a sheep. I don't know what it is. It is drawn in a stylized manner with a simple feature and a motion line. So in summary, you have you have provided a realistic photo of orange tabby cat, exactly, and the second one is a cartoon drawing of a cute fluffy pet. And the exact time it took was 4 minutes. Now what I want to do is, instead of sending two images, I just wanted to send only one, like this. No two images at all. Only one image, and let's time it. Okay. So 2 images took 4 minutes, 16 seconds. Let's see how much time only one image takes. And I think probably the image I've sent is of this cat, orange tabby cat. All right, so let's wait. So I don't know why it took almost 6 minutes, 4 seconds, but yeah, I think it has given us a description of a cat. Oh, the prompt didn't change. So yep, the prompt didn't change. That's one of the reason. What about now? So still, it took about 3 minutes, and yep, recognized it's a cat and it's outdoor. Background is slightly blurred. So yeah, like it's working. I'm not asking whether it's working or not. I'm saying it nearly took a lot of time, and my RAM is almost at 12.6 GB used. Uh, this much RAM is only given by the what is this, Colab, Google Colab, and that much is already getting used. The whole model is probably on red alert. Let's move on with our documentations. We'll finish it quickly. So we have well used this Python script. CURL, well, not necessary, but what does is it creates a variable called img where it takes the test JPG that you might have downloaded from this link using code, and it converts that into base64, and that same img is passed as well images over here. Yep, exactly as expected. And the stream is false, so well, you'll see the response at once. Okay. Embeddings. So what it does is it generates text embeddings for semantic searches, retrieval, and RAG. So if you've ever created RAG, what happens is you give it a text, you create a vectorized form of it, and you store that. And whenever you know you ask your LLM something about it, LLM also searches those vectors if it can find something very similar to it, and if it does, it also responds exactly like how the context you might have given it in a vector form is. Mostly 90% accurate. If you have given it a context about, let's say, biology, it'll answer biology questions far more accurately than any other questions. Let's say we used 5.3 model or 5.2 model. Let's say we have a Qwen, not let's say, it's not about assumption now. We have used Qwen 0.5b model. Now, this is not a very smart model, all right? It can't do even maths. But if I start giving it a more context about biology, let's say the whole knowledge, the whole, what I would say, the whole research papers and everything that has been published till date, feed it directly to this, creating a RAG. And then how do you create it? Using embedding Gemma and other models. And you can run them like this on the text. Yeah. And that will create a vector that can be stored in a numeric form. So let's try running it for hello world and we'll see the output. And it's awesome. See, just for hello world, this is what we get. And this is the actual backend of how AI actually works. This is just number. Exactly. If that number, let's say if that text would have been a little bit more, then you know what. Okay. So instead of doing this, let's do something more interesting. Let's take a Wikipedia page About what? About what? Let's see. Wikipedia, the free encyclopedia. I want a Wikipedia page. Some really nice topics you can think of. So this is today's featured article. Okay, okay. I don't know much about it, so I'll probably not give it. Let's see what it has for Arch. Oh, so now Arch Linux, but the Arch as in, yeah. So let's take the text, copy it, uh, paste the text, isn't it? As in text. And this is a long text, all right? And even some rubbish data is there. Does it matter? Not much. How to collapse this? How to collapse this cell? Like this is a very long cell. Well, you can't. I'm just taking too much time, I guess. Yeah, now it probably ran. And well, just see whether, just for demo, whether even Ollama embedding text even will run or not. What is it called? EMBE. Embedding Gemma. Okay. So it'll probably first of all download it and then we'll run this just to be sure. Ollama command not. Oh shit. First of all, run all. That will do what? That will first of all. I think, yeah, the well runtime expired, so this is probably a new runtime. So it'll need what the Ollama is and everything about it. So that's why I wrote in Colab. Instead, I could have used terminal, but I don't use terminal because it does not persist at all. But this does persist. So it's nice, and we are at well installing Ollama 40%. Okay. So okay, till embedding is running, we know what embedding does. It creates embedding as this thing, and then how to link it to, let's say, a model, a RAG. Does it give any example? No, it gives a Python code or curl code to create embedding. Okay. What if I give it this? What will I get? So I get this directly. As a long text. All right. Now I gave it is content type application or JSON. A model is embedding Gemma. It's already installed in my Ollama. If you have internet, lots of internet, well, then download these model offline. Or just think of a way so that you can download it or probably use Colab. I don't think Colab will be able to run it. What happened over here? Why did this cause an error? It says try yield exception rate. Connection refused. Oh, connection refused because we need to first of all call Ollama from here. Ollama, brother, where are you? So now it will run. Still doesn't run. Okay, chat with the model. Well, chat with the model, start. What's happening to you? Brother. Did it not install? Oh, at least pull something. I'll also say, oh yeah, Emily. Not run it because it'll probably get stuck. Not run it. Now this will run. After that, this will run, isn't it? And instead of asking a stupid question to a stupid model, let's just ask hi. It'll probably respond properly. Or hi. Oh, oh, surprisingly, is it close? 491. Well, well, well. Let's open up Python. Even I don't know what 17 times 23 is. 23 or something else. 23. 3, 390. 391. What the hell? It's not even close. All right, let's say hi to it. And hello, how can I help you today? All right, that's all you want to do. Why is it installing from scratch? Shouldn't it just install, from the cache? Did I say something stupid? Did I say something stupid? I'm not sure. Now text. I want to send this text properly. So probably I cannot use curl over here. So I'll have to write a Python code. So let's get a Python code from somewhere. So this will give us a Python code. And the input is the variable text that we have, isn't it? Not this, because these are, strings. I just want to send the whole text variable that we have. Oh shit, did I do something stupid? Control Z. Yeah. So we have a text variable, isn't it? If I say print text, will it print text? print text. Yeah, so embedding actually ran, and this is our embedding. Should we save it after getting the embedding? I think we should save it somewhere at least. And yeah, we have a text. And let's see if we send the whole text, how much time will it take? 7 seconds, 8 seconds, and so on, so on. So till it's creating an embedding of this whole Wikipedia page, including these stupid things that shouldn't even be there, but who cares? I'm just showing you how can we create the embeddings and store it in a vector format. Well, not right now. I'll not store it as a vector format, but yeah, it says that use cosine similarity for most semantic search uses cases, and for some embedding model for both indexing and querying. Use the use the same embedding model for both indexing and querying. Okay. Now it says tool calling. So Ollama, now we are at tool calling. Embedding is done. Ollama support tool calling, also known as function calling, which allows a model to invoke tools and incorporate their results into its replies. So calling a single tool. So invoke a single tool and include its response in a follow-up request. Also known as single shot tool calling. Calling a single tool. Invoke a single tool and include its responses in a follow-up request. So we called a tool, that is type function get a temperature, and object city, and city the type string description. So what is actually happening over here is we are saying what is the temperature in New York, and then we are saying use the tools that you have, and it will probably generate you know the message as it is. Yeah, uh, that's what's you know expected from it. There's parallel tool calling, uh, which is mostly the same thing. I've never used it, so I cannot actually find the difference and what it is doing. So let's ask someone who knows it. What is the following code doing? Very spelling mistakes. Lots of spelling mistakes are there. Who cares? This code is a basic example of tool or function calling with LLM using Ollama. It lets the model call your Python function to get a real data instead of guessing. Let's break it down simply. So from Ollama, we import chat, Ollama, API for Python. Now get temperature, that is city and string. City is of type string, and the output will be also of type string. So it defines a function that returns temperature to the for a city, and it's a mock database that is hard coded value. User message looks something like this: what is the temperature in New York? And this is the input to the model, like GPT prompt. And give tool a model. Something like response is chat Qwen 3, and message is the messages over here is variable. Tool is get temperature, and think is true. Okay, so it starts to utilize the tool that is get temperature, and that is also hard coded. So we should get the hard coded value over there. So this value is hard coded somewhere. Yeah, so New York temperature is 22 degrees centigrades. Uh, Sorry, Celsius, isn't it? What is centigrade? I don't think it is something. Yeah, so New York should give me, the temperature that is 22 degrees Celsius. So you pass get temperature as a tool, and the model can decide either answer directly or call a function. Well, it should call the function. So it will likely decide I should call the get temperature New York City. And if response message is tool call. So since it's okay, I get the point. So from our function that we have hard coded and created, it should probably give us the temperature of New York, that is 22 degrees Celsius. That's what we are expecting. And since it's using or utilizing a smart model, let's use our PC for it. So we'll create 6.py. Oh, 6.py, not p. 6.py. And we'll paste everything. And model will be Qwen for latest. Append latest. Isn't it? Let's verify. Ollama ls and exactly Qwen for, oh sorry, Gemma for latest. That's why I verified, because yeah, humans make stupid mistakes. Machines most of the time doesn't make these sort of silly mistakes. Anything else? Do I want to change anything else? No. Tool is called or function name. Function name is temperatures from here. Get the city, get current temperature for a city, argument city, the name of the city, and returns the, yeah. So you just have to pass. So we are also passing this string so that it can read through the temperature and get an idea of what this get temperature function does, and then pass the parameter as it requires. All right. And that's it. Okay. Message.tool calls 0. if response is message.tool calls, if it uses something like this, yeah, then we'll get something like this. Otherwise, well, good luck. Think true. So thinking is on, and we'll directly get the message.content. So no streaming, no nothing. We have to wait. So why not use a timer on that as well? If you are running it, I know it, but let's use a timer. It gives you an estimate of how much time it will take. It takes a long, long time. So let me shut up for now. Let me just see what has happened over here. Oh. So input was text and we got output as 1. Why? He sent you such a long text and you give me the output that is 1? Unacceptable. Okay, now instead of, hello run, what about I copy this? Isn't it? I paste it over here as in to use the variable that is text. Will it use it? No, it will not. What I should do, let's just stop it if I can. Yes. Oh, did I restart? Shit. What the hell? Okay, so what I'll do this time, I'll copy and paste this. Not manually, obviously not manually. Oh, let me duplicate this slide, or whatever this is. How to duplicate this? I don't know. Paste it. And well, it's still connecting. Why is it taking such a time? Yeah, ls is working. We'll get sample data. We got sample data. This will start installing. One more thing that I'm very curious about. How would I go to this link? Will I see the sh script or something like that? Oh, it directly gets installed. That was unexpected. Ollama.com, and then we'll say install. If I say install.sh, it just directly downloads the script. And I want to see the script. So instead of downloading it second time, let's open up the script and let's see what it does. Who is not curious? Who is not? Oh, it opened up in a browser? What? How does that make sense? Well, tell me, how does that make sense? Any of you? Let's open up a terminal. We'll say nvim and paste this. What happened? Nvim, paste this, and pasting doesn't happen. So let's go to download and install.sh. Yeah. So this is what install.sh script looks like. This is, well, it says that you are creating a script file. So it's called shebang and then bin and sh. Interesting name, shebang, because it's hash or sha, sha, and this is bang, so shebang. This script installs Ollama on Linux and macOS. It detects the current operating system architecture and installs the appropriate version of Ollama. Wrap script in the main function so that a truncated partial download doesn't end up executing a half script. Okay, so main function is there. We have described the main function. We have set EU so that if it fails, it does something. I don't remember what it does. red, red. Oh, red. And then user bin tput bold set it. Not sure about this line as well. Status, not sure. Error, not sure. Temporary directory, sure about this one. And after that, it cleans up the temporary directory that it has created. Okay, trap the cleanup, exit. Available command, require local missing for tool in whatever dollar. Available tool, missing tool. Done. Echo missing. Uname, arch, case, AMD, unsupported architecture. So it supports 2, it doesn't support the next one. Verbam. Oh. So it gave us a response, not what we expected. 4 minutes and 28 seconds. So what happened? What went wrong? Is there no pip list? Like, yeah, it is available. What is the error? Ollama response model Qwen. Oh shit. Did I just change the model? 3.5. This is the model. So what are you telling me? Is it this as well? Final response 3.5 and then latest. Okay, they should have created one single variable where you can directly unexpected indent. Are you kidding me? I didn't even indent anything at all. Oh, seems I did. Yeah, so this was the original indentation, and then I pressed nothing but append and latest. You see, it automatically indents. Is it my fault? Nope, it is not. Now what? What are you waiting for? Start here. Okay. We were reading through the sh. How many lines are there total? There are 445 lines. Okay. NVIDIA persisted. All right. Mod probe, NVIDIA, UVM. Interesting. DKMS status. Whoever wrote this, it looks beautiful. Beautiful. ETC OS release is used. Like if I show you what happens in ETC OS release, should I cat it or yeah, let's cat ETC and then OS release. Yeah, so whatever the name is, like my operating system name is Arch Linux, it shows you. All right, that what happens in where were we? Yeah, OS version, OS name, package manager, DNF, yum, apt get. Okay. ETCOS release. Error unknown distribution. Skipping CUDA installation. Sudo, well, for Linux, sudo is everywhere. I think for Mac also, sudo is there. sudo apt-get y, like for yes, install CUDA driver -q. Depackage apt-get update and so on. Quite interesting. AMD GPU. Nice. So I also wrote some sort of script files, but they are not so descriptive. Like this is figuring out all the hardwares, all the GPU, CPU, everything, even your repositories and everything. Like, yeah, this is quite in general. So you can run the script directly on WSL as well. So see, WSL. WSL. Think about that. Microsoft Windows. Hmm. This is what it sets for. This is not good, let me tell you. This works for you, then you are perfect. But it certainly doesn't work for me. So I had to edit this after so much, I don't know, errors, try, and everything. Jetpack version, Ollama install directory. Well, sometimes it uses the directory of root var, like variable, and inside that probably var lib and Ollama, var bin Ollama, something like that, or var lib Ollama. Depends. Sometimes it just uses the dot Ollama. Depends here. I don't know how it figures out where to install it, but it does get installed. In Arch Linux, ZSTD should be installed. So yeah, while installing it in our Colab, we had to write a command about ZSTD. See, ZSTD have to get installed. Instead of directly pulling Qwen 5 model that we don't even want right now, we want this Ollama package. Just to make sure Ollama is running, we'll download this. It's not. We probably run further in terminal and craft it. Yeah, so it's running. Not much of a problem. Embedding is also there. So since everything is there, let's make this text a terminal text. How about like this? Now this is a terminal text. What this means is it is stored directly in the terminal. Somehow. I hope so. My hopes are high. Very high. Alright? And this is the Python text. So if we somehow use Python, we'll use it. If we directly use Ollama run and the text, embedding Gemma and text, this is the reason why I hate mouse. I hate using mouse. Instead of running this, I should directly run this. Model require input text usage. Your text here. Oh, it doesn't take this as a text. Why? What happened? Is it not even valid? Is this? Oh, sorry. Let's somehow. Is it not valid? I am entirely not sure. Over here. How about this? And run it. What it says? Invalid decimal literal. Notch is curved vertical. Okay. I think it's a syntax problem, syntactical problem. How about now? I run it, still the same error. Is it the same error? Let's ask someone who knows about it. In terminal, I want to store a variable or a const called text as, you know, text and multi-line sentences, and then this, let's make it multi-line, right? In Colab, how to do it so that I can run this what? I want to run this command without any sort of errors. Without any errors. So it says we can't do this. Yep, correct way to do it is this, and directly call the text. That's what it did. But does it work out? Let's figure out. So instead of, playing with the whole damn text that we might have created, let's name it txt. Txt. This is different, right? txt. Will it work? Will it work? Will it work? Will it work? So it works. All right. So now we got the clue how to run it. So probably delete this, right? Delete this thing. This is a ruckus. This is our text. And to pass it, we must use double quotations. That's all. Run it. It ran. Now run this. It says syntax error near. Oh, whoa, whoa, whoa. 547. Let's give it the error. And we are facing some sort of error. Resolve this. Yeah. If we can print out the text as echo, probably we are getting the same text we should have gotten. Echo and run it. Will I get the same? Oh, whoa, whoa. So I ran into the same error. Let's give it. The error isn't about line 547. It's about your shell command breaking due to special characters, especially parentheses and quotes. When bash sees something without proper quoting, it thinks or starts a subshell syntax error. So what happens, while your text contains quote, parentheses, maybe new lines. So echo plus shell is expansion is unsafe for complex text. Best fix is use stdin safely. Will this work? Will this work? Let's see. Let's see. So this worked. Now instead of creating this text, let's comment it out, and we know what text is. So Let's run it again. And yeah, we got our results. Nicely done. How long is it? How long is it? Not quite long. Why not? I'm not sure. So this failed. This failed because the text had syntax errors like parentheses and all those things. We cannot do that, but we can do this. So this worked. It's good. Now what was this? Let us see. Oh, we sort of moved to the final boss where it should have used tool. If it didn't, 22. Oh, nice, nice, nice. This time it actually used our tool and it gave us the temperature that was hard coded. So yeah, it worked for the first one at least. That is 22 degrees Celsius. This is parallel tool calling. So what it does is we have get temperature and we have get conditions. All right, and conditions is also hard coded, and it will call both of these tools all together. So what we can do is, well, create another Python file. Well, do tell me if it's getting confusing, if I am, figuring out two things simultaneously. Well, because I am very familiar with what I'm doing, but you might not be. And before running, because this will run into an error, before running, we should change the model from Qwen 3. How to change it? Oh, I knew something like %s or something like that. But let's change it manually for now. Yep. At the end, append from 5 and latest. Isn't it? Go to the next word. At the end, append with 5 with latest. No error should be there now. I'm gonna take much, whatever time it takes. And this processing with tool calling, it almost took about 4 minutes. It's nicely done actually. So parallel tool calling, we must get, is it asking about New York or something else? Oh, message is this, New York and London. So yeah, this will take time. It definitely will. New York has 22 degrees Celsius and it's partially cloudy. London is rainy and has a temperature of 15 degrees Celsius. So it has to figure it out. Let's see if it does in 4 minutes, or does it take more time than that? Because you're calling two tools parallelly on two different datasets, New York and London. Let's see how it performs. So when we create agentic AI, we could use tool calling something like this. We define the tool that you want to use, but let's say we want to create an file, a .py file, isn't it? Write a code, or let's say write a code in HTML. So we want to create a .html file, and we have a function for that in a skill set. Now, how will it decide which tool to use? Should we pass all the tools simultaneously or parallelly, or like how should we actually pass the tool? So for that, I think we must take it to a little bit dumber model, which can take the user prompt. Think about it. of what sort of tool it must use and everything about it from skills.mt. But then Dumba model cannot take, large context and prompts. So that's also a problem. So either we can pass all the tools available, basic tools, or we can call the same model twice. First, to figure out which sort of things you want to use, and second time to actually execute it. No, that's more complex. So it'll take time probably. We should read something about. So parallel tool calling doesn't have any sort of documentation. It just has two functions, get temperature and get condition. And CURL also looks kind of easy to read, but harder to write. If you have to replicate something, you will probably replicate this Python or JavaScript, whichever is you are comfortable in. Multi-turn tool calling, agent loop. This is what I want to read about, and it is there. So an agent loop allows model to decide when to invoke tools and incorporate their results into its replies. So it also might help to tell model that it is in a loop and can make multiple tool calls. Okay, so let's say add to numbers, arguments like, okay, so our Dumbo model was not able to perform addition. Will this tool calling help our Dumbo model to actually perform the addition? But our Dumbo model cannot also think. So I'm not sure, but if it can be possible, I would love to see it, because it can reason now. If it wants to add it, it will add it on the rules of BODMAS. We can also give it the rule of BODMAS, isn't it? So there's add, which adds A and B and returns it. There's multiply, multiplies it. Available functions is add and multiply. So two functions is there. Message is, what is this big operation? That is 1143 and 12341 multiplied by 412. And then while true, so it's in a loop. A response, chat response, which is of type chat response, is equals to chat. And the model is Qwen 3. We'll use 3.5 latest. And message is this messages. And tool is add and multiply. Think, well, it is true for now because it can think. But Qwen 0.5b cannot think. So will it be able to perform that? I'm not sure really. But Qwen 3.5 should be able to perform it. It can even perform addition by itself. So it doesn't even need this sort of tool, but it's good. It's good to give it. Message.append is response.message. Then thinking, and whatever it's thinking, it will print it. Context, response.message.context, but it will not, stream it. So yeah, this is what we got. Response.message tool call is we are using for TC like tool call. In response.message.tool calls, if tool call function name in available function, print calling and TC function name with arguments. A result is available function, TC function name and dash dash dash. What is this? TC function arguments, tool call function arguments. And we are printing the result, and message.append role is tool name is TC function name, and content is string of the result. Whatever the result is, we'll append it. Else what? Break it. End the loop when there are no more tool calls and break the loop. Continue the loop with the updated messages. Okay. So till our model is running the parallel tool calling, or is it done? It's running. So we'll try, just try. Yeah, there's nothing bad about it. Either it will run or else it'll probably not. We say hi over here. Will it work? It should work. There's no problem over here. I'm not sure. I think we are printing the length, that's why. It's giving us this sort of response. Oh, we shouldn't have deleted it. Yeah, so it does that. Now what we'll do is going to be interesting because we'll be using 0.5b over here. Okay. It cannot think. So we'll not get anything something like this. Thinking is not there. What else? What else? I change something else. I should probably, but I don't remember what else should I change. Think true. Yeah. This will cause errors. Damn, it already caused an error. That is, Ollama library does not support tool. Oh, it flags that Qwen 0.5b does not support tools. Shit. And we don't have Qwen 3.5. Even if we have that, well, it cannot support the 3.5 itself. So we are stuck. We cannot use Ollama. No, we can use Ollama, but we cannot use it on Colab one bit. Now what is the error? What is the error that you are getting? 3.5 is not found. Not a big problem. We can, whenever we want, we can pull. What is the name? I always forget the name. 3.5 latest. This is good. This is not. Then we must do something called Ollama ls. And it'll not be able to run because, well, there's some sort of virtual cap of how much RAM it can use. It cannot. I don't know how, but I realized it is there. We cannot avoid it. Now this parallel tool calling is taking more than 4 minutes, I guess. So what should we do? Well, there's nothing except for let it run and then wait for the response till the. Oh, that's why my computer is hanging. It's actually using 100% to think. Well, damn. I think I'll wait and I'll cut this portion if it takes a long time. So, well, it gave us an output. For New York, it is good. For London, I have to cross check. Well, it took almost about 48 minutes. So, well, that is quite a lot if somebody thinks about it. So London was also 15 degrees Celsius and the condition was rainy, wasn't it? London 15 degrees Celsius and condition was rainy and it was partially cloudy and 22 degrees. So almost all the time, like all the time that it had, the 48 minutes, would have gone for the thinking to proceed. So that's what I guess happened. Now, if I try to run this multi-turn tool, which is, running in a loop, that'll be a bigger problem because we won't know whether the loop will end, whether it'll not. So let's try to run it. And like this took about 48 minutes. So I'll probably just cut it in, final editing. So let's create 8.5, not 7, but 8.5. And wherever it's Qwen 3, we should make Qwen 3.5. So yeah, so voice was there. I thought I was muted. Wherever we have Qwen, we should make it Qwen 3.5 latest, L-E-T-E-S-T, latest. Yep, model is latest. What else? I think it's good. So let's run Python 8.py. Let's time it as well. So we'll time this one as well. So if 8.py, let it run. Well, it already gave us the result that he wanted, but it's still running in the loop. So will it run forever? Will it stop sometime? I'm not sure. But yeah, the result is actually correct. If you add 11,434 with 12,341, you'll get 23,775. And if you multiply that with 412, you'll get exactly 9,795,300. Now, I just have to see how does it stop the loop. That's what I want to see. And it's taking time for that. So I think that the Qwen model is actually thinking. So let's see how much time it takes. And this is not like the result of it. It's actually thinking, and now it must be formulating of how to say the user or just give the end result to the user, something like that. So let's wait and see what it does. Somehow, this model with two functions available for addition and multiplication ran for just 10 minutes and gave us the actual result. And that's really like accurate result. Whereas this model, with just had to process the information that it had, that New York has a temperature of 22 degrees Celsius, and same with London and their conditions, it almost took about 48 minutes. So I don't know whether this is so random that we cannot even figure out, or it's somehow, we could also use temperature, like the temperature as an, like we pass prompt, we can pass temperature as 0 so that just think straight, but then it would not be creative. And to think, everything needs to be creative. So I think we have to, tinker with that. Otherwise, yeah, this is absolutely mind-boggling to me. Now, this is what we call agentic loop. And nice. But it took about 10 minutes, and I would say it gave the results in almost half or quarter of it, but it just waited for the third loop to end. That is thinking the calculation is complete. Let me summarize. The first, that is addition, is this much, and the multiplication is this much. So the total will be this, 9 million, so on. Content was this. So yeah, the calculation was done in two steps. First added these two numbers, A and B, and then multiplied the A and B and gave the result. So this is now what time it took, about 10 minutes. So earlier it took almost about an hour, that is 48 minutes. 48 minutes. And this one actually took 10 minutes. And I'm feeling quite proud right now. I never imagined it would turn out like this. And it will be able, it is actually runnable. We ran it and it worked. Okay. Now tool calling with streaming. So when streaming gathers every chunk of thinking, content, and tool calls, then return those fields together with any tool results in the follow-up request. So let's see what it does. So it has a get temperature and it returns the temperature messages. What is the temperature in New York? So yeah, so New York has 22 degrees Celsius. Now while true, so we are running in loop. Chat from the Qwen 3.5 model latest, we'll use that, and message is the same. Tool, we have get temperature. Stream is true and think is true. Think was earlier true as well, but over here now stream is also true, so we'll get a stream. Now thinking will be stored in this, content will be stored in this, and tool call will be stored in this array. Now done thinking is false, but when it is, it will become true. Okay. Now for chunk in stream, if chunk.message.thinking, and like this is exactly what we are looping over the stream now, and each and every stream has two things, message, and inside that either content or thinking. So for thinking, we'll get thinking, and we can append thinking to this, thinking plus equals to chunk.message, and we'll print that as well at the same time. All right, and we'll print it and we'll store that thinking in this thinking variable. Then for content, we'll do the same. If not done thinking, then done thinking is equals to true. Like, if the thinking is not done yet. If not false, isn't it? Done thinking is false. So if not false, then it'll make the done thinking as true. So it'll become true and it'll print the next line where we will start printing the content, isn't it? So this is the content statement. Okay. So if content.message.content has something, chunk.message.content has something, that then this statement will run first of all, which will make the thinking is equals to true and get us a new line. Then we'll start content and append whatever the content is inside this variable at the top, and then we'll print the content at the same time. And we are doing the same thing with tool call as well. So we are saying tool calls.extend and chunk.message.toolcalls. So this is the parameter that we'll get in the stream. And extend is the Python thing that we use to append in. Why didn't we use append? I think we used extend, so it doesn't matter, it just gets added to this array or list, I don't know. Now it prints the tool call as well. So if thinking or content or tool call, messages dot append role assistant, thinking for thinking, and content for content, and tool calls for tool call. All right. So it appends the accumulated field to the message. And if not tool call, then it breaks. So if there is no tool call, it'll break. And for call in tool calls, if call.function.name is get temperature, result will be the get temperature and it calls the function argument. Else the unknown tool, which does nothing, or even I'm not sure what it does, unknown tool. But if this works, like it should work, but I'll still be amazed because yeah, this is something new to me and probably new to you as well. Oh, when, isn't it? So we should go to the end, append 3.5 latest. And let's run with timing because timing is important. How much time does it take to run this Python 9.py? So I ran it, I ran it, and let's wait for the output. Nicely done actually. And the next subject or the next topic is with shit. I saw something. And that was not something I should have seen. Response is sent to well. I should stop it. There is 2 Qwen. Well, I only got 1 over here as well, I guess. It is not. Why not? Oh, so this is another. All right. So this is something else. This is what we ran right now. Okay. No problem, no problem. Just me being not so smart right now. This loop streams the assistant response and accumulates the partial fields, passes them back together, and appends the tool result so that model can complete its answer. Using function as a tool with Ollama Python SDK, so the Python SDK automatically parses the function as a tool schema, so we can pass them directly. Schemas can still be passed if needed. So from Ollama, import chat, and same thing, and it returns the temperature.get and the city. It also has an unknown to it, if it's unknown. Available function is return temperature, and response is directly this. Directly pass the function as a part of tool list. Okay. Available function dot values. It directly passes, the function as the tool list. So this will actually not do anything because we have a response, but after the response, you must do all these steps, isn't it? You must either make it in a loop or, stream the chat to a model and then get a message and all sorts of things. So we have chat, but we are not parsing through the response. So we'll get a response, but we are not printing the response. So I think that's where we are stuck. All right, we'll still run this thing. Now let's wait for this to process a 9.py. So it gave us an output, and I hope that this was the thinking. It's not the actual response, but it's all mixed up because, well, we did not separate it, I guess. But yeah, let's see what it gave us. So the user is asking for the current temperature in New York. I have access to the function called get temperature that can get the current temperature for a city. I need to call this function with New York as the city parameter and tool call. So this made a tool call called function, and function was name, get temperature. Argument passed was city and New York. Now tool call, I hope, is something that Ollama already provides because I did not define that tool call. So it's actually making the tool call. So I don't know how it works. So it has already some abstraction that needs to be studied if you want to get further how it's actually calling the tool. All right. The function returns return that the current temperature in the New York is 22 degrees Celsius, and I should provide this information to the user in a clear and helpful way, right? So this was the answer after line break. The current temperature in New York is 22 degrees Celsius. So this was the thinking and tool call as well, and this was the actual answer. And it almost took about 5 minutes. Earlier, it almost took about 4 minutes. What is the difference over here is we are actually streaming this. All right. Now this is the last code. We'll probably not get to see any sort of results or responses. So we have to be, let's time it and run Python 10.py. What is this? Messages is not defined. How is it not defined? Let me see. So messages, yeah, it's not defined. And yeah, 3.5 latest. Message is still not defined, but that was the error. Shall we define messages? Let's define messages from the above one. Not this loop, but this one actually. No, this is also a loop. No loop, no loop, no loop. We want no loop. Messages, and then response is, we already have response. Okay, we have messages. We still have error. That's what I want to see, because we are not, passing through the response and we are not printing it. So that is the next error. So it will probably process for the amount of time it will take, but it will not give us any result. So to get the result, you have to do this. Or should we? Well, since we know already, so we shouldn't do that. Let's just see what it does and what it gives us. And we'll move on to web searches. And web searches is something that we need to, log in or sign up for Ollama, because we need authentication and API keys from Ollama so that we will be able to web search. And yeah, Ollama API key is actually required. And I'm not sure whether it's for free or not. So I'll probably never use web search, because models are powerful, but my computer will not be able to process it. So I'll probably never use a web search for now. But in future, if we need it, I think it will be free or it will not be free. But in future, what can happen? I'm not sure. Now Python library, use this and the print response. The response we get as a result is in this format. But in Python library, where are we sending the this shouldn't work. So, oh, let's close this. All right. And let's open up Python directly and let's paste this, isn't it? Oh, this will also not work because no module Ollama is there. So to make Ollama available, we must go into file. How about I just open up another terminal and take it to workspace 4. Source venv bin activated it. Now we do quick list. Yeah, we do have. Now if I say Python and in interactive shell, if I try running it, yeah, it gave us authorization header with bearer token is required for web search. Okay, so we cannot use without the API key. Without getting the API key, it's not worth it. So till this, Python 10.py is running, I think we should stop, but we'll not get anything dramatic. So we should not expect anything more. But let's see what the web search is from as an overview. If you need to do the web search, well, just go to the Ollama and follow these instructions. Ollama API web search is where you post the request. That's a end key. But to get an API key, you press over here. It asks, well, I'll probably, how about, I'll do it later on. All right. I'll try it for myself. But yeah, I'll probably not need it. Not for now, because, it also has to process all the results that it gets, content and all with the URL. And then it has to give you the final verdict of what it thought. So the whole thinking process will take, I don't know, 1 day or what. It almost took 48 minutes to just process something very simple. I know it's AI, but still, a human using a calculator is much faster than that AI. And calculator is something that we use in, but all right. I get the point. AI is intelligent computer itself. Human has to just ask. So I get the point of using AI, but yeah, so these are the format for CURL, but what's important is Ollama API key. And that's what you get after signing up. Right? And I'm not sure whether it's for free or not. I hope it's for free, the web search, but it might not be for free, so no idea. JDK, SDK, JavaScript. All right. Building a search agent. So it can use a 4 billion parameter model and can actually search for the web, which is actually amazing if you think about it, but still. And it shows the result because it knows most probably people won't be using it. Or if they will be using it, well, they should be using it, not something bad. Manage MCP servers or configure MCP servers at the following configuration. Where? In C-line. So Ollama's web search can be integrated into C-line easily using the MCP server configuration. All right. In Codex as well, we can integrate the web servers, web search, and other integration as well. So let's move on from web integration. And in integration, we get an overview of where these coding agents can be used, like Cloud Code can use Ollama, Codex can use Ollama, OpenCode can use, and Droid, Goose, Pi, everything can use Ollama. Assistants, so like OpenClaw and Hermes agent. So OpenClaw with Gemma 4B, latest model E4B, is actually a great combination. If you think about it, Gemma 4 is absolutely nuking the whole, thinking business because it is so damn fast and efficient at context saving. That's what I've heard about it. I've not benchmarked it, so I'm not really sure about it. But yeah, for chat and RAG, we have Onyx. For automations, we have N10, and for notebooks, we have Arimo. So all these overview is there, but we'll get into deep instruction manuals. So these are the instructions. So if you need to follow it, well, you can. You're free to go and follow this. I'm not sure that I will use it. Gemma 4 reasoning and code generation is almost about 16 GB VRAM, like in GPU or something. 3.5 is 11 GB. It's almost there. 10.7, 11 GB, yeah, almost there. And this non-interactive headless mode, this is run OpenClaw without interaction for use in Docker or CI/CD or script, anything. All right. Connect messaging apps. Yep. Hermes agent is there. Ollama pull, then you'll probably install Hermes agent. Yeah, Hermes agent install.sh. So it's a script that will install Hermes. And the setup would look something like this: quick setup or full setup, depends upon you. And the connect to Ollama by the API base URL. That is this base URL. Exactly. Leave the API key blank, not required for local Ollama. Yeah, obviously. But it is required in certain cases like cloud and all those things. Detected model, use this model, yes or no. Leave the context length blank to auto detect, and context messaging launch. Yeah, you can go through it. It's an amazing doc. So when I faced problem for systemd and setting up this whole Ollama thing, this actually ran, and this must have given us some sort of response. Oh shit, let's not run it again. But since we are not printing the response, or not even looping through the chunks or whatever, so it's not showing us anything. Let's print the whole response thing. Yep. This is a very rude way to do it, rudimentary, but still it'll print at least something. And it took almost about 4 minutes, which is not bad. Now Cloud Code. So you can integrate Ollama into Cloud Code. So this is for installing Cloud Code. This is to launch Ollama for Cloud Code, and then we'll pass the model that is there. Now, since we are using cloud, you know why? Because cloud can handle large context They are on powerful machines, so well, no delays at all. And most importantly, I'm not sure whether you agree or not, but if you want local AI and it goes to someone else's server, I think you defeat the point of it being a local AI model. Probably just purchase some OpenAI keys or API keys or Anthropic's keys. So because this thing can work for you if you want to, but we use Ollama just for the sake of using it locally, using all sort of models locally for web search and all those things. Yeah, you can use Ollama launch Claude and with Telegram, all these things. All right. Manual setup is you have to give all these authentication tokens, API keys for Anthropic directly, and just use Claude code like you do. If you use Ollama with it, you'll probably regret, because Claude code actually gives you large prompts. Don't even think about using it with Ollama. This is Codex. I'm not sure because I've never used Codex. I'll probably use it in future, but I'm experimenting it, and my space is nearly 50% fill. So yeah, somewhere in the future. Open code again, AI agents, nice. And same with Droid and this Goose and Pi. These are all agentic AIs. Well, no AI is there. You have to connect an AI to it, and it'll act as an agent with lots of skill, and your AI will actually utilize that skill. You can connect Ollama with IDEs and editors. You can chat and RAG with Onyx. So this is Onyx. Looks really nice to me. I'll probably install the Onyx, but then see what sort of model is it's using. GPT OSS 120B. Just think about it. Is the most powerful open source model available, but also something that utilizes large PC. So if you have this much amount of RAM and PC on your hand, then you probably won't face any sort of money problem. So just buy a damn API key for whatever you need. And for the privacy, yeah, you're good to go with GPT OSS 120B. I don't think that there's a better model than this. There can be. Gemma 4 is beating it. For consumer grade laptops like mine, I'm using Gemma 4 and it's giving me a great result. Still running. And we'll see, the raw JSON file as a response. Right. NA10, if you have used NA10, well, you get an integration directly for Ollama. Just use it normally. But still gave this, instructions as a formality, I guess. Now CLI reference and some setup modules you might need. So to run any models, we use run Gemma 3 or whatever the model name is. To launch, we say, launch the integration and let's like Claude or OpenCode, whatever. Isn't it? VS Code, Droid, whatever. We can launch it. Multi-line input can be written with, 3 double quotes. And after writing 3 double quotes, just start typing. Don't try to close it. Otherwise, it will give you an error. Okay. Multi-model. So let it finish, and I'll probably demonstrate 1 or 2 things from here, and then we'll move on, like multi-input, multi-line input, and multi-model. Multi-model models. Okay. Yeah, it's a multi-model because it has 2 modes, text and images. It can process 2 things. And I've already shown you this. We have passed images as a criteria, and it actually processed it and gave us the result. Generate embedding, we also ran this, so we know how it works. We can also echo this directly. So what it does is echo hello world does nothing, but prints out hello world like this. Oh, what happened? Oh, I missed this double quotes. So let's do it again, but properly. Yeah, so it just does this. And if I use a pipe, so what it does is whatever this echo gives as an output, that is hello world, the pipe will take it as an input for the next criteria that you might have written. Let's say you want to create a file called hello.txt, and you want anything that is coming as an output from here should get as an input for the cat, which will append to a hello.txt. So if you first of all ls to see what's there, you get a hello.txt. That's something we expected. But let's see, do we see the hello world as it is? Yeah, so we do see it. So it means the pipe does nothing, but it takes the output from the first thing we passed, that is echo, and it takes the output as an input for the second parameter after pipe. That's pipe for you. So hello world gives us the hello world, and we use it, or we pass that as an input to this Ollama run and nomic embedded text, and this hello world gets passed to it. So it's like embedding Gemma, embedded text that creates the embedded text. All right. Now to download a model, we can pull it. If you start, Ollama run Gemma 3, so it'll pull it as well as run it if you don't have the model. But if you have the model, it will probably run it. To remove a model, what did I do? To remove a model, we just have to say Ollama RM. That's how we remove it, right? We remove anything exactly like that. Like I want to remove the hello.txt, rm hello.txt. So that's a Linux command, and it is quite very close to actually Linux command. If I say Ollama ls, which is ls to list files, but if I say Ollama ls, it actually prints the list. If the ps is a process command in Linux as well, so you see all the processes are there. And if I do Ollama ps, it actually gives me the process for the Ollama as well. So it is very close or synonymous to all the Linux commands that are there. So if you say rm, and I've actually shown you how to remove any model. So yeah, it'll probably remove a model for you. I don't want to remove anything, so I'll probably not remove it. Now to sign into Ollama, you can use Ollama sign in. Sign out is just Ollama sign out and whatever the criteria is. Now to create a customized model, you have to create a model file and then pass whatever model you will be using. And if you want a system prompt, like you are a happy cat, or you are a happy dog, or you are called a Tommy, your name is dash dash dash. So it will be created as a model file, and then that model file will be used as an input to create another model with whatever name you specify. All right. But over here, we are not doing anything else except for we are creating a system, and the Gemma 3 will actually become a happy cat for you, and it will start responding like that. Okay. So CLI references enough. Assistant sandboxing. So we know NemoClaw. What is NemoClaw? NemoClaw is something that NVIDIA open source developed it. It's a very security stack like a wall. So when you instruct an AI to do to sort of prohibit from doing something, it is sort of a door. Imagine there's a door and you're telling the AI to not go through that door, because after that door there is probably some danger, some snake or tiger. But since there is a door, someone can exploit that door and actually make the AI go through that door, like remove a file or something like that. But what this NemoClaw does is actually give a very tight security such that it makes the door disappear. So you cannot, the AI cannot even access that door. So it's like a wall over there. And even if you try to sort of, hack it such that it can pass through the door, but it will not even find the door. So where to pass from? So that's what NemoClaw is. That's a basic introduction to it. So it's a security stack because it separates from what it can do and it has the permission to do and everything else. It's a very secure thing over OpenClaw that you have. So it wraps the OpenClaw with NVIDIA OpenShell runtime to provide kernel level sandboxing. Think about that. Kernel. Linux is a kernel. It's not an OS, it's a kernel. Network policy controls is there, audit trails for AI agents. So to start, you have to just pull a Nemotron 3 nano, 30 billion, and run it inside as a curl like this and connect with whatever. I will not probably do this because, well, of my systems. It says it requires 4 vCPU minimum, but I only have this much, so I'll not probably run at minimum. RAM is I have 16 GB RAM, but still, disk space is not much of a problem. Node.js and npm is already installed. Container runtime, Docker, we already have a Docker, but still, CPU is the bottleneck over here. Yeah. So over here we got our result. Thinking process was like this. The user is asking about current weather temperature in New York City, and I have to access the get temperature function that can get the current temperature for the city. I should call this function for both New York and London to get their temperatures. However, I should note that functions only return temperature, not full weather condition, but I can provide information I can get with available tools. Let me call the function for both cities. And image is none, tool name is none. So like image parameter, you can pass for Qwen 3.5. So it already, so if you don't pass any parameter, it already passes as none. All right. And if you pass something, then you did something good. So it also has a tool name parameter obviously built into that model. That's why we were able to use tool name and tool calls. Now it's making a tool call to function called get temperature. Okay. And the argument it passed is New York City. And the tool call will actually call it and it will happen. And the argument will be London City as 2 cities there. Log props, none. And it made tool call and everything, but we still don't see the response. So probably we didn't get a response from that. Or we didn't probably handle that response. All right. So what I wanted to make you see is well, Gemma 4 is quite heavy. Let's use some lightweight models like this, Gemma 2B. Okay. First, we'll see its info. So we'll say set info. Oh, sorry. Set what? Oh, not set, but get. Or what was it? Did I show info? Sorry, my bad. I was actually thinking about whether it's a thinking model or not, but yeah, something happened. So it's a 3 billion parameter model. Context length is 8,192. Embedding length that we can embed is 2048. Quantization is Q4. It has been quantized. Capabilities is completion. It can complete. And parameters, licenses, Gemma terms of use, all those things. All right. So we already have info. What about if we try setting the think? Will it think? So it says it does not support. It's such a small model. How can it even support something like thinking? But still, it's set the thinking model on, so it will probably not even answer us. Yeah, isn't it? So we have to set no think. Yeah, now it works. I'm unable to access external commands or resources, including the ls command. I am a large language model. We know, trained by Google. Yeah, Gemma is mostly trained by Google. Not mostly, Gemma is trained by Google. Okay. Model file references. Now it's all about model file. To create a model file, I'm not going to create a model file over here. And we can play with context length as well. Context length, like whatever the 8,000 was, we can change it to less or more. I don't know what will happen if I change it to more, but Something bad. That's a meme, no? Something bad will happen. All right. So this is, I think, instructions to install for Linux, for macOS, and for Windows, and then for Dockers. So I've tried mostly Docker and Linux. macOS is very similar to Linux, so probably three of them. Windows is something that is left for now. I'll probably switch to Windows and try it out. Who cares? Yeah. So I've tried this Docker, and to make this port bind to our actual, because I use Ollama and it's actually bound to 11,434. So either you can change this to something like some port, some random port, let's say 11,342, whatever. All right. But don't use this port. But for Docker, the internal Ollama will be connected to this port. But for your PC, use whatever, 8,000, 9,000, 10,000, whatever you want to. All right. Otherwise, it will create a problem for you, because if you have local Ollama installed like this, you have to either unbind it or unserve it, stop it, whatever. So instead, just change this port number and you are good to go. And this is something even GPT cannot figure out. Like if you say that it is causing a problem, it will say that your port is busy. So try doing something with your port. Try stopping your Ollama model first. It'll even make you delete it. So I've tried it 6 months ago. Like I faced the same problem when I was learning Ollama with Docker, and it said remove the local Ollama model. I said why, and it had no idea, and I had no idea that I could do something like that. But instead of deleting something, like, think about it, how much of internet I must have spent on this. Think about it. 2 GBs to install this, 4 GB. This is little. 1.7 GB, and including these, approx 1 GB, including this one as well, 1.1 GB, 1.6 GB, 9.6 GB. And this is not two times. The second time, it just got a second name, so nothing different. 4.7 GB and 6.6. So think about that. It's a very heavy models that I have actually installed. I can actually copy it because I know where it's installed. So let me show you something. ETL, and what is it? I'm also edit. Edit, no? LLaVA. So this is the service. So I have to figure out by myself. It's still wrong. I'm not entirely sure of what's happening, but something related to port and host was there. And the second problem I faced was sometimes it uses different paths. Like sometimes it uses something like, what should I say? Sometimes it uses the path of, let me show you, root variable over here, var a lib and Ollama, something like this. Yeah, see? Oh, what's happening? So sometimes it uses this directory, which is, I would say, not good. In case earlier when you said Ollama serve from here, and it actually started serving and you installed certain models, it'll probably use some directory like over here, Ollama. So my all models are stored over here. So sometimes if you start with system CTL, it'll probably take this as an home root or whatever this is, working directory environment. Sometimes it takes this one. So now I have to figure out. So it was long. See, this is its default. It takes var lib Ollama, and sometimes it takes this directly home and user and Ollama. I'm not entirely sure why it does that, but yeah, it creates a lot of ruckus. So let's close it. Well, I didn't edit it, so no need. to do anything else. Clear it out. Okay, so I have shown you most of the problems that I ran into. So I hope you won't run into the same problem. But if you do, be patient and run the read the docs. This is the most important thing. Yeah, I actually figured out everything through the docs because GPT was not at all helping at that point of time. And from then and there, I actually took the screenshot and saved it. So whenever I ran into the same problem for host and all, it is not serving and I'm getting a CRUD problem. CRUD problem? What? Is it a CRUD problem? No, it's what? Course problem. Sorry, my mistake. My bad. It's not a CRUD problem. CRUD is something like a SQL thing. Course, CORS, cross origin reference, something like that. What is CORS? CORS, course, full form. Cross origin resource sharing. So it'll probably be running on, not entire machine like 0.0.0, but something like 127.0.0.11434, something like that. And that causes the problem. That's the entire source of problem. Or you can create a middleware and pass through it, try to pass through it, but still you will probably face multiple problems. So instead, just change the whole Ollama, serving file. Now it's telling you how to import a model like this. Nicely done. Actually, if you have ever imported a GGUF directly, if you have a model and you are trying to import it, yeah, this is how you do it. And frequently asked questions, and this is something I really want to get into because, yeah, that's something people ask. So how can I actually upgrade the Ollama? Just run this script again, and it'll actually install it again. So this is how you update it. How can I view the logs? So troubleshooting, you can use journalctl and all those things to view the logs. Is my GPU compatible? So for that, hardware support, inside that you have GPU docs. You can see there. I don't even have a GPU, so I don't care. How can I specify the context window length? So let's say I'm running something and I have to specify context length to 8192 and then say Ollama serve. So that's what I was talking about. And use Ollama serve. It uses a different directory. So the problems you might face over here is you might not see any models at all if you do Ollama ls. Then you have to figure out where is my model actually stored, and then you remember it. Or when you run directly, you can set like this. So let me see. Ollama, where are you? So shall we use this? No, Gemma is important. So we shall play with Qwen. And we'll first of all show the info about it. So it has a context length of about 32,700 seconds. Think about it. Parameter 620 million. So not much of a context, but context length it can take about is insane. That's insanity. So let me paste this so that it reduces the number of context. All right. If I say show info, oh, context length didn't change from here, but it said that it changed the number of context to 104. I'm not sure about it. What happened? But how to recheck whether it did comply with us or not? How can we be sure? Okay, Ollama PS. So if I say Ollama PS, Ollama PS. Yeah, so our context is set for about 4096. So let's remember this number 32768. All right, let's exit it and escape. Not this, but Ollama PS. And now it shouldn't be running, even if it is. What case? What if I want to change the context back again? So I'll say set context, but instead I'll pass the new number. That's 32,000. No, let's first of all try it. If I say hi, if I start blabbering, oh, oh, it understood. Nicely done. Context length is 4,000. All right. Now let's set context length back to 32,768. So what it did was, what is happening? What is happening with me? Okay. Still no change. I'm not entirely sure what I did. Or even how it could even affect me. I am not entirely sure. Hi. And show info. It was always the same, but over here it should have changed. It's not. So what should I do? Yeah, it's not changing. I'm not sure. Okay, so when it shows 100% CPU or 100% GPU, it means your model is loaded in RAM or CPU or GPU, whatever. If you have both, then it will probably show you something like 48% on CPU and 52% on GPU, something like that. Now, the second question is, how do I configure Ollama server? So probably, Ollama host and do this. So it's telling you to set environment like this. I am not sure whether it works or not because I directly had to edit the whole Ollama serve file. So, yeah. If you face this sort of problem, just come to FAQ and, try doing this. Probably this will work. Probably this will not. Depends. And it's showing you that you can set up the whole environment variable like this. And yeah, this will actually start working. And then you have to do something like systemctl daemon reload because you have changed the daemon. It's called daemon, DAEMON, that sort of daemon. And that's why it's called system D, no? D for daemon. Yeah. So you have to reload the daemon after editing it. To edit it, I've shown you, it has also shown you the command that is systemctl edit and ollama.service, but it will probably give you an error saying that you don't have the permission. So you'll write a sudo at the front of it and then write the same command. And then in the service, you have to change the environment from the earlier environment to this one, Ollama host, reload the daemon and then restart the Ollama process. That's what you have to do. And probably just use sudo for most of the command because you'll face the problem. Now setting up environment variable on Windows, I'm not sure because I don't want to go to Windows anytime soon. How do I use Ollama behind a proxy? So Ollama pulls models from internet and may require a proxy server to access the models. So use HTTP proxy to redirect outbound requests through the proxy. Ensure the proxy certificate is installed as a system certificate. Refer to the section above and blah, blah, blah. I'm not sure why we are using proxy and installing it from there. So we are creating a model file, I guess, from Ollama. We are creating a certificate. And yeah. And for Docker, we are doing the same thing, but with a proxy and whatever the link is for the proxy. Now, this is the important question. Does Ollama send my prompt and answer back to ollama.com? Now, it depends upon you whether you like how much you can trust. Ollama company is owned by which company? Like, I think it's by Meta. Ollama is owned by which company? See, everybody has asked this. And after asking this, well, Ollama is not a major tech company like Meta. Independent startup, Ollama. All right. Associated with Meta's Llama model due to its ability to run them locally. It's separate entity. Oh, it is. Its own open source software to facilitate local Llama execution. Now, all of a sudden, my all the questions and speculations vanished because yeah, if Meta owns the Ollama, then probably whatever is written is not true. But if it's open source and yeah, so I probably get confused because of Llama because the first model I ran on Ollama was Llama. So yeah, Ollama runs locally. We don't see your prompt or data when you run locally. When using cloud hosted models like whichever model like Kimi and all those models that has cloud to it, and you need API, we process your prompt and response to provide the service, but do not store or log that content and never train on it. Well, I hope it's true because it's open source and well, we are all using for the security purposes so that our prompt doesn't go to some AI farms. Now we collect the basic account info. Okay. Limited usage metadata to provide the service that does not include prompt and response content. We do not sell your data. Well, somehow, in modern era, it's very hard to digest that somebody is saying we don't sell your data. Even Mozilla started doing. Well, all right. I won't go into that. But yeah, Mozilla also betrayed us. Few months ago, I guess, in 2025. Yeah. You can delete your account anytime. Now, how do I disable Ollama's cloud feature? Ollama can run in local only mode by disabling Ollama cloud feature. By turning off Ollama cloud features, you will lose the ability to use Ollama's cloud models and web search. See, that's why I was not able to use web search because I was quite, you know, I don't install OpenClaw in any sort of these AI agents because giving them access to a computer and not knowing what's underneath them is far more dangerous than spending time and actually understanding what's going behind or on the backstage, actually seeing and understanding all the logs that you can see. Otherwise, think about it, only one line will change in the company's terms and condition and suddenly your privacy is not yours anymore. And you know how much of a bargain you are getting right now because of the cheap plans. Everybody is trying to poach uh, you and your data into their own guild, trying to give you more personalized experience on AI so that in future if it raises its price or it is not available for this cheap, you will still have to depend on their models. But think about it, they just have to change one line and freaking your data is not yours data anymore. Your code is not your code anymore. All right, I'll not get into it. But since we are using, you're already over here and you have watched this much. So it means you are concerned about your privacy and you want a local AI model so that you can run based on your compute. If you have a good compute like Mac Studio or something like that, cluster of it, well, good for you. If you don't have it, well, still good for you because there are still some general level models, 7 billion parameters, 12 billion parameters that you can run with just 32 gigs of memory and a little bit better CPU. I hope. I'm the one with no CPU. Oh shit. Ollama can run local only models by disabling Ollama's cloud feature but you won't get the web search and cloud models. Yeah, that's the conclusion. And to do that, you have to create .ollamaserver.json. Let me see if there is such file called ollamaserver.json. ls Ollama and what? Server.json, isn't it? Oh, not here. Sorry. Server. So there is no server.json. Config.json is there. Config.json. Not ls, but cat it, or let's say less it. So integration, whatever, last model, last selection, run. And if I say disable cloud, let me do it. Let me do it. Let me do it. Probably use nvim. Oh shit. Hmm. What happened? What? How this works? And disable Ollama Cloud. You can also set up the environment variable as Ollama no cloud. I don't want to use Ollama web search for now. I'm not planning it anytime soon. And after that, restart the Ollama change config, and once disabled, Ollama's log will show Ollama cloud disabled is true. So I truly believe environment variable is something that will try to strictly follow. So I'll set it there also. I believe you. All right. And let me show you how to sudo sys oh shit system ctl uh, dae daemon reload. Yeah, so it reloaded it, and system ctl restart the Ollama. Yep, that's 2 lines after editing it. The next question is, how can I expose Ollama on my network? So, Ollama binds directly to this port by default, but change the bind address to by changing the environment variable for Ollama host. As I've shown you, you can change it anytime soon. Not a big problem there. Next question is, how can I use Ollama with proxy servers? Like proxy pass, proxy set header, and this is not something I'll use, but Ollama runs on HTTP server and can be exposed using proxy servers such as NGINX. We all know about it, Apache, NGINX, and all that. To do so, configure the proxy to forward request and optionally set required headers. If not, exposing Ollama on the network, for example, with NGINX. How can I use Ollama with ngrok? So like I am using Colab. Now after using Colab, I can probably connect it with ngrok to serve it from here. Or if you are on your own computer, you can probably use ngrok, but then you have to sign up on ngrok and get an API key or environment key, whatever the key is from there as well, and use that to get a link. And that's how you do. You can use probably Cloudflare tunnel. That's what I truly believe in. But the link doesn't remain the same. I don't know for ngrok it remains the same or not, but Cloud Tunnel, it doesn't remain the same. Every time you refresh, you'll get a new link. And to use Ollama with Cloudflare Tunnel, use this. And Cloudflare is something that we all know about. ngrok is something we all know about, but I'm not truly sure who owns ngrok and what is their terms and conditions. Ngrok, see, I actually authenticated, so auth token. ngrok is owned by Elon Musk. No, which company? ngrok is an independent, privately held company known as OK. Nicely done. It was founded in 2015 by Alan Shivers, headquarters San Francisco, California, and venture backend by investors, Lightspeed Venture Partners. All right. So it's an independent company. Nice to know about it. How can I allow additional web origins to access Ollama? Well, just change from this to 0.000. And you have to allow Ollama origins and or allow all Chrome, Firefox, and Safari extensions like this. So for browser extension, you will need to explicitly allow extensions origin pattern, set Ollama origin to include all these things. Where are the model stored? This is a great question. Now see, If it shows you something like this, probably it's true, probably it's not. In my case, it's not. Okay. It's telling me there is no such file, but Ollama is there. Okay. But inside that, it has nothing. If I say, well, show me the hidden files, still has nothing. Why? Because we know where my uh, models are. And if I want to back it up, I'll just back it up from home directly. Sometimes it goes to variable and lib Ollama, as I've shown you. So check out your whole, everywhere, everywhere you can find. Go to its config, try to edit the systemctl ollama.service daemon, and even if not edit, just try to read it. Not don't use sudo, because sudo will actually give you permit to read and write through it, but just use directly, edit systemctl edit ollama.service, and it'll open up in neovim or something like that. All right. And okay, it's cleared, so I cannot show you. Where were we? Over here. So this line is not absolutely true. This is not absolute. So how do I set a different location? You can use model environment in model Ollama models and choose a directory of your choice. How can I use Ollama in Visual Studio Code? Well, you have already seen how to use that. Everything else, why is networking slow in WSL2 on Windows 10? Now this can impact both installing Ollama as well as downloading models. So when control panels on, okay, I'm not getting into that. How can I preload a model into Ollama to get faster response time? So there's an endpoint, isn't it? You just use directly generate and it'll preload it. To use chat completion endpoint. So to preload a Mistral model using generate endpoint, use this. To use chat completion endpoint, use this. I don't know what is difference between generate and chat, but when we'll see API reference docs, you'll probably know about it. And or to preload in CLI, we can do this. So it'll preload it. Preload means what? Let's say I am not even running something, but if I say Ollama PS, see, no, nothing is there. But if I say Ollama run, and what is the mode? Qwen 0.5b. And if I say run this, but I'll not even pass anything like this in a headless mode. So it'll probably try to run it and it will not give you anything because you have not passed any prompt. And suddenly it's loaded and context has not improved yet. All right. I'm not sure how to improve that. How do I keep models loaded in memory or make it unload immediately? So if I say Ollama stop, whatever the model is, like if you want to unload it, just say instead of run, you have to say stop and it will unload it. So if I say, well, show me the process. Yeah, it has unloaded. Or it will unload it after a period of time. So no need to worry about it. Okay, so if you're using the same model for an API, if you say keep alive and -1, it will probably keep the model alive. And this is for default behavior that, it unloads and free of the memory use. So that's what default is. -1 is actually to keep it alive, leave the memory in use, so that it'll probably respond to you very quickly. That's you can pass as you pass the prompt. After the prompt and messages, you can do this, keep alive and -1. Alternatively, you can change the environment. We shouldn't do that. It's not good because, yeah, you need to, give some space for your RAM and all. Now, how do I manage the maximum number of requests Ollama server can queue? So Ollama max queue and adjust that. How does Ollama handle concurrent requests? So it says Ollama supports the 2-level of concurrent processing. So if your system has sufficient available memory, system memory, and using CPU inference or VRAM or GPU inference, then multiple models can be loaded at the same time for a given model. If there's a sufficient available memory when model is loaded, it is configured to allow parallel request processing. If there's a sufficient available memory to load a new model request while one or more model are already loaded, all new requests will be queued until the new model can be loaded. As prior to model becomes idle, one or more can be unloaded to make room for the new model. Now, queued request will be processed in order. When using GPU inference, new model must be able to completely fit in VRAM to allow concurrent model loads. Okay, so we shouldn't be reading this because my CPU, my hardware doesn't even allow it. So I don't know. How does Ollama load models on multiple GPUs? I don't even have GPU. How can I enable flash attention? What is that? Flash attention is a feature of most modern models that can significantly reduce the memory usage as the context size grows. To enable flash attention, set Ollama flash attention environment variable to 1 and starting Ollama. What does it do? I'm not sure. How can I set the quantization type for the KV cache? The KV context cache can be quantized to significantly reduce the memory usage and flash attention is enabled. So to use KV cache with Ollama, you can set the following thing as F16, F8, whatever. F16 is high precision and memory usage is default. Q8 is 8-bit quantization, use approximately one half of the memory. So half of the memory of F16. So F16 uses the default, whereas it uses the half of the default. With a very small loss in precision, this usually has no noticeable impact on model's quality. Recommended if not using F16 directly. Okay. 4-bit quantization use approximately 1/4 of the memory of F16. So nicely done. What about F8? How much cache quantization impacts the model response quality will depend on model and the task. Model can have a high GQA count. Like Qwen 2 may see a larger impact on precision from quantization than models with a low GQA count. Where can I find my Ollama public key? No need to find it. Wherever your model is, you will see your public key. I've already shown you mine. See? Not a big deal. How can I stop Ollama from starting when I log in? So don't just use systemd. Like instead of using systemd, disable it. So if I say not this, if I say sudo systemctl and status about Ollama, and let's close this window. So you see, we see that it has been enabled. If we disable it instead of typing status, I had typed enable to enable this service. If I type disable, it will probably disable it. So after a reboot, it will not start automatically. You either have to say Ollama serve or just start it from here. Systemctl start Ollama.service every time. And if it's not active and running, you have to start it. Preset disable, well, I am not sure what this does, but preset disable, I am not. I don't know. Okay. Any more questions? For hardware support, well, it supports multiple CPUs, GPUs, anything else. Troubleshooting. So this is important part. For logs, use journalctl all these things. For Docker logs, use this Docker PS to find the container's name if you don't know already. Okay. Nothing that I can use right now. So I think I have finished one documentation. Our API reference is left, so we'll cover it up. So API reference, there are 12 endpoints. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. So 12 API endpoints that we get from Ollama by default. And let's read about API references. So this is introduction. Ollama's API allow you to run and interact with model programmatically. Obviously, that's what API means. Now get started. So if you are getting started, follow the quick start documentation for what? Quick start documentation? Oh, it's to just install the Ollama, launch it, and well, get started with the API first over here. But we want to get into depth. So to get up and running the Ollama's API, we know base URL always like base URL for OpenAI is what? ChatGPT.com API/generate or something like that. V1 API. Let me search. ChatGPT base URL API. So this is like ChatGPT is OpenAI's API completion. HTTPS API OpenAI.com and V1 chat completion. All that. So same, but this is just localhost because we are running it locally, right? But if we are not running it locally, like we are running it from Ollama's server, like we are running a model that uses cloud, we have to use this URL, ollama.com/API. So for running cloud models on ollama.com, the same API is available with the following base URL. So, same API, but the base URL has been changed. But the APIs remain the same. All right. Now we have an example request. Once Ollama is running, its API is automatically available and can be accessed via curl. Obviously. So if we run this, what will happen? It will first of all send to generate, which will take our request for model, that is Gemma 3 prompt, that is why is the sky blue, and will give us the response. Okay, so we already know what will happen. So instead of using Gemma 3, let me use Gemma 2b. That is also a model, but a little bit faster and a little bit dumber. So it's initializing it, I guess. Yeah. The sky appears blue due to the, what is this, ray light? I think there's some spelling mistake as well. Scattering, the blue light has a shorter wavelength than other colors of the light, so it is scattered more strongly than what? This is effect caused by molecules in the atmosphere interact with the wave. Oh shit, it's going too fast. Okay, so you know the reason why sky appears blue, but it also gave us the reason why sky appears blue. And at the end, this is the context for our next window that we can take. All right, like for the next time we chat to it, we should pass this context as it is so that it knows what it was earlier talking about. So that if it's something relatable, like why sky is not red, so it'll take this context into its mind, like, yeah, this person has asked already about why sky is blue. So yeah, from the context, it will estimate how to answer you and all. Now, total duration, load duration, prompt evaluation 28, uh, prompt evaluation in this much duration, evaluation count 98. So there are 98, I guess, tokens and so on. Now, this was how we got started. So what is API over here? This API generate, and we are sending it a request for the model and a prompt. That's it. We are not sending anything else. Yeah, we are not. If this would have been an image model, uh, it would have some image parameters, which would be none by default. But if there was some image, it would become the path of that image. As simple as that. So libraries. Ollama has official libraries for Python and JavaScript. Python, we have seen, we have installed Ollama. library as well, and several community mentioning. So we have a Git repository. If you want to check it out, well, do check it out because it's nice. So yeah, this is Ollama. It's written in language Go. I think Go is handling the API and all. C is interacting with most of the models because it's fast. Go might also be doing that. TypeScript and all, I have no idea. Shell, uh, Shell is so that we can get started by installing it, all those things. Okay. So it's using REST API. So Ollama has a REST API for running and managing models. This is what we did as a message, role, content, model. But our message was very simple as a prompt that why is the sky blue? Now in Python, we have installed the Ollama, isn't it? And we have sent some of these requests to the endpoint for a response. What this chat does, it already knows the endpoint it wants to hit. That is API/chat. This is the same thing, right? If we do something like a message or something like that, it'll do that. And now there are multiple things that it supports. Okay. So we can figure out the libraries for both of these. Oh, not again. And versioning. So Ollama API isn't strictly versioned, but the API is expected to be stable and backwards compatible. Depreciation are rare and will be announced in the release note. Okay. It's going nowhere. You can use the same API. Why is it not going next? Authentication. Is it hanged or something? Yeah. Authentication. So authentication is like auth key or something like that. But we don't require API keys and all that. So no authentication is required for this base URL, that is localhost 11434. So no authentication is required when we are accessing the Ollama's API locally via this localhost. Authentication is required for the following: when we are running the cloud models, when we are hitting the Ollama.com directly via Ollama.com. Yeah, publishing models. Yeah, we need to be signed in so that we can publish model. Downloading private models, then also we need authentication or API keys. So Ollama supports two authentication methods. First of all, sign in from your local installation, and Ollama will automatically take care of the authenticating request to Ollama.com when running commands. The API keys for programmatic access to Ollama.com API. Okay. Now signing in, you have to sign in. You just have to say Ollama sign in, and yeah. So it'll probably give you some browser's link. You have to go and, you know, as always, how you sign in, you do that either through mail or create an account on browser. Yeah, it'll happen in a browser mostly. And then after you've signed in, you can run any cloud models, isn't it? I'm not sure whether it'll take money or not, but this is open source. They are giving us cloud for free. So what are they getting in return? That's what I'm very concerned about. Similarly, when accessing local API endpoints that requires cloud access, will automatically authenticate the request. Like if we are doing something like localhost API generate and we are using a cloud model, but it will need a authentication. So if we don't, I have not authenticated, I am not signed in. So if I send this request, it will send me an error that I am not authenticated. Yeah, it says unauthorized. Why? Because I don't have any API keys that I can send. Now API keys. So for direct access to Ollama.com's API key served at this Ollama.com API authentication via API key is required. Okay. Now you can go to this link, get an API key, create an API key like this, but for that you have to sign in. So Yeah, Jesse, sign in. And since I don't want to sign in, then after that in your environment, or you can just directly export this, so it will be stored in your what bash rc. So yeah, you can store Ollama's API key environment variable like this, and then use API key in authorization headers. So while authorizing like H, and you can say we are authorizing, and the bearer is the Ollama key variable that you might have exported already. If you don't, well, you have to do this first of all with your API key over here, isn't it? And then you can use this variable as it is like this, and the same request as always. So API keys don't currently expire. However, you can revoke them at any time in your API key settings. All right. Now streaming. So we have seen what streaming does. Well, it gives you token by token response every second. So it's like very interactive. But at the same time, you have to get inside message and then response and then take that response to yourself. And you have to check whether done is true or not. And if done is true, you stop taking the response. So that's streaming for you. Now we can directly disable the streaming by saying stream is false. Okay, so stream is false will give you just one JSON file with one response, and you can directly parse through that response to get your response directly. So in the request body of an endpoint that support streaming, and this will cause response to be returned in application JSON format instead. Exactly. Let's say the same thing over here, but instead I would say stream is false. Shit. How do I get the next line? Am I stuck? Doesn't matter. I'll just say over here stream stream now. Stream and false. Are you sure? Let's see. Now it will not stream probably like this. This was streamed, but now it will just give me a response block with the whole response so that I don't have to, figure out word by word. Like over here, I had to because there was no other choice. Yeah. So what you got is a response block that has our whole response. Where is it ending? Over here. And then done true as always, but not done false for few streams. We directly got done true at once and the whole response in it. And done reason is stop and all those things, context and all. All right. But our response is not just token by token, it's like the whole response is there. The sky appears blue due to the this thing. This thing is very wrong. I think it's small model, so it's hallucinating. All right. So we now know streaming is false. What will happen? You'll just get when streaming is true, you will get token by token response and you have to parse through it. When you disable the stream, you'll get a one response and then you have to pass through one response and get the whole response at once. When to use streaming versus non-streaming? So streaming is like by default. So it gives you the real-time response generation. As soon as it generates a word, it'll give you that. So that's streaming for you. Lower perceived latency. So what do you perceive as a latency? Like you had to wait for nearly about the same time for both of these when I streamed and when I did not. But the perceived latency or the perceived time that you had to wait was less when you use streaming. If you don't use streaming, you have to wait a long time because you think that model is running or not. You get lots of questions if you're doing streaming is false for the first time and you just want to test it. Don't do that because yeah, you'll take a lot of tension. That's not good for your health. Now, better for long generations, because if you are doing something very long, generating something very long, just stream it one by one, because otherwise it'll take such a long time that you won't even be able to figure out what's happening, what's not happening. And you have to wait for, I guess, 48 minutes. Like, yeah, we waited for 48 minutes just to get one response, isn't it? But since it was streaming, it was still easy going. Like, yeah, we knew that it was working behind the scene. Now, non-streaming is a simpler to process. We directly get into response directly and get the whole response at once. It is better for short responses or structured outputs. So everything is very short. So, short responses is preferred, because if you have a long response and you want to wait for that much of a time, yeah, it's not very comfortable. And structured output, because you don't have to do everything by yourself. Like when streaming is there, not there, sorry, when streaming is there, when streaming is true, what I have to do is actually separate word by word if there are any spaces or not. How should I combine them? Everything. Loop and all on the chunks. Now, non-streaming, just get to the response, take the response, parse through it, show the response. Easy. Easier to handle in some applications. Yeah, as always, it's very easy. But the price that you pay is not very interactive. You perceive higher latency than it is a usage. So Ollama API response include metrics that can be used for measuring performance and total model usage. So total duration, yeah. Where are you? Is it cleared properly? Let's get that. And yeah, we've seen this total duration, so how long the response took to generate. Load duration is how long the model took to load. Now, I don't know if it's in second, microsecond, what? Okay, nanoseconds. So they are measured in nanoseconds. All right. Now, load duration is how long the model took to load. Prompt evaluation count is how many input tokens were processed, and prompt evaluation duration is how long it took to evaluate the prompt. Okay. Evaluation count is how many output tokens were processed. Evaluation count is how many output tokens were processed, I guess. Spelling mistake. Evaluation duration, like how long it took to generate output tokens. Nicely done. All times are measured in nanoseconds. Now, example response. So let's say, we sent a request like this and we got a response. So response says, hello, how can I help you today? Nice. So this is the formatted response that we got from here. All right. What you can see is we have a model that this model responded, created at and the time, the response in just one response, and then done is true. Done's reason is to stop, and then you get a context. But over here, this is what we are talking about: total duration in nanoseconds, load duration in nanoseconds, prompt evaluation count. Well, just as a count, 1, 2, 3, 4 count. Prompt evaluation duration is in nanoseconds again. Evaluation count is 61, and evaluation duration again in nanoseconds. So yeah, this is exactly what we get at the end of it. Now for endpoint that returns streaming response, usage, fields are included as a part of final chunk where done is true, like this, and run reason is stop. So it is included but not used properly because we are not streaming. Anyways, so errors. So we might get sometimes the error that is status code. Status codes, we must remember, it's like a browser, but sometimes it's not. So 200 is success, we all know that. 400 is bad request, like missing parameters or something like that. Let's say, let's do something stupid. Instead of saying Gemma 2b, what if I make a mistake of not including the semicolon? It says error model Gemma 2b not found. Now we did not get the error code because we were not using API as a request, you know. But when we will be using it in browser, we'll get these responses as a success or a bad request, invalid JSON, etc. 404 that is not found, that model does not exist over here. 404, all right. 429, many requests. So when rate limit is exceeded, which it can. 500 is internal server error. That is either for Ollama or sometimes it's your server that you might be using as an backend. So yeah, be aware of it. Whose server is down? Where is the internal server error? If it's an Ollama, well, figure it out. If it's in your own backend, then also figure it out. 502 is bad get. 502 is bad gateway, like when cloud models cannot be reached. That's when you get 502. Now, error message is something like this, where errors are returned as in the application JSON format with the following structure with error message in the error properly. So you'll see error and the model failed to generate response. Over here, we got error, that is model, Gemma 2b is not found. Proper error. We know what exactly it means. Error that occurs while streaming is like an error was encountered while running the model. So you are streaming and it did not finish. That's what I guess. Yeah, it's not finished. And you get an error that says encountered a problem while running the model. So error is very interactive over here. You can know what happened, how it happened. You can troubleshoot a little bit. Okay. OpenAI capability. So now this endpoint is not something this Ollama should have provided, but since it was trying to copy the format that OpenAI's API does, so it's doing that like V1 and then chat and completion, something like that. Exactly. So they also created a, I guess, synonymous. All right, it's not doing something very amazing. It's the same thing as the completion that we already have, but in a different manner. It's doing the same thing as you can just, instead of importing Ollama, you will import OpenAI, and you might be using OpenAI, but sometimes you want to test it locally. You don't want to spend your API keys. All right. So you'll say the base URL is this, that is localhost 114.11434, that is Ollama, and then V1 is included because that's how OpenAI's API works. And then API key, you can send anything or leave it as is. Don't do anything with API key because it will ignore it. So required but ignored. Now chat completion is equals to client chat completion. So exactly, chat completion. See that? Chat completion. What is the client? OpenAI with this base URL. So in this base URL, chat completion will be added like this. And then you will create a message for them that our role is user, content is this much, model is this. You can, interchange it, like model first, message at the model first, message after that. Yeah, you can always do that. Not a problem. Then you can print the chat completion choice as OpenAI does or gives you. So yeah, it's like compatible with OpenAI's sort of schema, if I would say. And if you want a simple response, not a completion, but a simple response, so you can use this. This is exactly how OpenAI is used. So yeah, it's good actually. And this base URL thing, you know, instead of sending it directly from here, like you are creating a very large application, you wouldn't do that. You know why? Because environment variables are created because of this. So you'll actually create an environment variable and you can change it from there, tinker it from there if you want to. And that's it. So let's say you've created the whole uh, presentation creating model. All right. Something that creates presentation. And then what you want to do is actually take the base URL as an environment variable and make a variable over here, and whatever this link is, don't take it as it is like copy paste, but take it from environment dot, get environment, and whatever the base URL value is from the environment, take it over here. Same for API key, uh, give it in your environment variable. To create an environment variable locally, just create a file .env, and while you are deploying it, you will get an setting to somewhere, set your secrets or whatever. So in Colab also we get something like that, but Colab is not used to, Colab is not used. Colab is not used to deploy your application, but where you will deploy your application, you will still get some secret or set environment variables or something like that. So that will not that will not be a problem for you. Now, rest of these things, model, I would say, like, yeah, take this model and make a call from environment variable, or if you know that you will shift later on to some model called, let's say, what is the model called? Let's say OpenAI. All right, we don't know the model's name, but let's say OpenAI. Then what you should do is two things. Either you can right now use Qwen 3 Qwen 3 8 billion parameter model directly, or the next thing you would do is actually copy this model as a different model's name. So this will the model at the back in your local host, but it will become a synonymous to some other name that you want, and you can directly write hardcode the model name over here like OpenAI, and it'll actually work. And we have seen how to copy a model, isn't it? We also did it, so not a big problem. Now input is something like a prompt, and after that your response gets sent, and then you are printing the response result output text. Not a bad example. So let's copy each of these. Why is Ollama not working? Okay, now Ollama is there. Connect. Get an ls first of all. Yeah, it's connected. Let's install Ollama. Then we'll also pull the Qwen 0.5b model, and we don't actually need it for now because we'll be using OpenAI, so we have to install pip install OpenAI. Uh-huh. Let's not code it over here. Let's do it before that. model you will use is Qwen, isn't it? Yeah. What is the error? Connection error. API connection error. Connection refused. The above exception was direct caused by the following exception. Error number 111. I am not sure. So is it something related to OpenAI? Let's ask it. What? Oh, Ollama sir. Shit. Yeah, this is something we all have to do. I have to open up the terminal and use Ollama so that we could actually use Ollama. But still the same error. That is model is not found. Why is it not found? Oh, we did not even install the model. My bad, my bad. Actually, that's what happens most of the time. Ollama needs to be served. Now we have a Qwen 0.5b model, and now if you run it, we'll not stumble into any sort of problem. That's what I hope. Yeah. So yes, I am a test. How can I help you? Yeah. So it worked with a V1. All right. Now we'll probably use V1 completion, V1 whatever. This was our first example for V1 and chat completion. Now we will use response. So let's also take this and paste it. So this is our next request. API keys can be, any random stuff because it's required as a parameter that yeah, API key is there because you are, following OpenAI's something. But when it will send this API key directly to Ollama, it will probably ignore it because localhost doesn't need API key. Now, what is the problem over here? It says message model. Oh, whoa, 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 whoa. We know that. This is my bad. 0.5b. Write a short poem about the color blue. Blue, oh blue, a hue so soft, as a light as a breeze, in nature's embrace, a hue so deep and strong, an energy that runs wild, a color that evokes so much. I don't know. Uh, like, yeah, it's a poem, but generated by a 600 million parameter model. So, a color that invokes so much and fills us with delight. No, it doesn't. So let's cherish this hue that makes us feel alive and free. For blue, it's the essence of our existence and alive. See, nicely done. So we know how responses work. Chat completion with vision. So, well, well, well. Now we cannot do this in our collab. So, because there's no vision model there, but we have vision model over here as Gemma, Ollama, LS. So vision model is Gemma or Gemma, whatever. Where is uh, Gemma for latest? So let's create a Python file called 11. Paste it. Let's change the model's name, that is from Qwen vision model 8 billion parameter to something that we know about. That is Gemma 4 latest. Now, this is data as image or PNG. Now we've sent base 64 and this is the image. And if you want to know what this image actually is, what we have to do is actually copy this till here. Let's yank it, exit it, and first of all generate the image so that we can at least compare what that image is. So I think I've created something called, yeah, convert base 64 JPG to image. So we'll go to curl and then convert and we'll actually paste it like this. Add some double quotes to it. Get it a variable called img base 64 and equals to, change this variable name so that it does not get processed. And what else? At the end, home end, and now this will process image base 64 variable, that is this one. So let's run it. Python curl convert what did we get? Output.jpg. Let's open up that output.jpg. The same thing. All right, so Ollama. Yeah, what did I even expect? Just to be sure, let's get into curl. Let's remove this output.jpg. Let's run, see the ls first of all. Let's run the Python again. But I'm pretty sure it's the same, Ollama mascot or something like that. And if we open up the output.jpg, yeah, it was the same thing. So we knew, but we still want to test it. Now, if we run 11.py, it will probably describe it as furry animal or something like that. A mime or no module name OpenAI. So we have to do pip install OpenAI locally as well. So yep. After saying pip install OpenAI, we shall wait. Now let's run 11.py and wait for it to give any response. Well, it ran, but we didn't see any sort of response. Why that can be the case? Well, let me ask the GPT itself that why am I not getting any response? Oh, sorry. 11.py. And we'll copy it. After running we did not got any response. Response. And my spelling mistakes are getting horrible. Okay. Yeah, very close, but there are two common gotchas in what you have written. What do you like that way? Why you are getting no response? So what's wrong with the model or image? You're using Gemma 4 latest are text only. They do not support image input. Well, they do. So this will silently fail and return nothing. A vision capable model, for example, LLaVA. Okay, we'll do that. Now, Open AI compatibility is partial. So Ollama's OpenAI compatibility with API does not fully support the structured content like this type and then type image URL. It expects plain string content. So current working version for Ollama that is best for use is this. But instead I wanted to use OpenAI, no? That's why I did that. All right, we know this will work. Option 2, fix your OpenAI style code, text only. If you want to keep using the OpenAI, then remove the image part. If we've removed it, how do we get any response? So I think, well, there's some code error over here. Something that I don't know about, isn't it? Type text, type image URL, and then the image URL. And it's not taking it as an input. And as for Gemma 4 latest, let me show you. I might have already shown you, so no need to worry about it. What's the image about? And then, the image name, that is, well, let me ls. It's called test.jpg. So yeah, see, it has added test.jpg and we are using Gemma 4 latest. And it'll actually respond. So we got a response, and the response, well, really recognizes that it's a tabby cat. So Gemma 4 actually works. So it's a vision model as well as text model. So I don't know what this GPT is spouting nonsense. I did not expect that. But it must be something else that is creating the problem. And I can't figure it. I can't figure it out because I'm not that much of an expert in using OpenAI libraries or even Ollama libraries. I mostly use request, right? That's the max I'll go. Now, endpoints like we have chat completion. What it does is supported feature is chat completion, streaming, JSON mode, reproducible outputs, vision, tools, reasoning and thinking control for thinking models, and log props is, I think, not there. It's not checklist. Now, supported request fields is that models, message, text, image, base64 encoded image, or image URL is not supported. So, yep, base64 encoded image. Array of content parts, frequency penalty, presence penalty, response format, seed, stop, stream, stream options, include usage, temperature. This is important. This is what I want. Top P, max token, tools, reasoning effort, that is high, medium, low, or none. Reasoning, again, reasoning and then effort. So inside two brackets after reasoning, the same thing, or you can just write it in just one bracket. Tool choice and logic bias and users n is not there. Now for completion, That was for chat completion, but this is for just completion. It has completion, streaming, JSON mode, reproducible outputs, and then supported request fields is model, prompt, frequency penalty, presence penalty, seed, stop, stream. Stream options include usage, and then temperature, top P, max tokens, suffix. Now, best of echo and logit bias, users and n is not there. All right. So note that prompt currently only accepts a string. In V1 model, the API notes that created corresponding to when the model was last modified, owned by corresponds to Ollama username defaulting to library. Now we can say something like V1 models and whatever the model name is. What this will do is created the corresponding to when the model was last modified and owned by corresponding the same thing. Now there's V1 embedding, so it supports the request fields. Nicely done. V1 image generation. So it's experimental because in Ollama we cannot generate image. To do that, we need stable diffusion and comfy UI and all that. So I'll also make a video upon that so that we can get started with comfy UI and some image generations locally. It'll take probably 10 to 20 minutes in just CPU, but yeah, it'll give you a fair generated AI generated image. Just make nature's image or something random like color mosaic or something like that. Don't ever try to make a person from that because you know you will get creepy dreams at night if you try generating person from API from OpenAI API. What we are doing now is image generates and then we are using model whatever that is. We don't have that yet, or do we have an image generation model? Not quick start, but let's go to ollama.com. What is this model called? XZ image turbo. Let's see if we have something like that. Yeah. So does it generate the image or what? Text to image model from LLaVA Stongy Lab. It generates high quality photo. Oh shit. So it means we can even generate images. And the installation is about 13 GBs. So I'll probably try it because I didn't knew before seeing this. I didn't knew that this sort of existed. And we can generate images using Ollama. Now that's fun. And it's not cloud, so we know we can run it locally. And this is something we would like to generate. We would like to take as latest, isn't it? And I'll probably read more about it. It's a 6 billion parameter models, text to image. So if you write a text, you will get a response as an image of B64. Then you have to convert that B64 into an output PNG or JPG, whatever. Nicely done. Photorealistic output, strong at generating realistic photographs, portrait, or scenes. Bilingual rendering, so accurately renders for English and Chinese text and images. Apache 2.0, open weights available for commercial use. Oh, we can use it commercially. A cat holding a sign that says hello world. Nicely done. Damn. It also saves. Shit. I have to try it. Alright. I'll probably install it and my RAM capability is all about 16 GB. So let me ask GPT whether I can run this image model or not. So I am using NG. I really miss a powerful computer. All right. You can probably run it, but not comfortably. I don't want comfortable. I want it to just run. It won't generate image anyways. Why? Despite the name, it is labeled as text model, not an image generator. So it likely does not generate image, does not accept image, just a large text LLM. The system versus model. 2 cores, 4 threads. Why are you laughing? Why are you laughing? Is it funny? 16 GB GPU like shit. Can you run a 13 GB model? Technically, yes, but practically it will be very slow. So yeah. The system RAM will be almost fully consumed, so I won't be able to use anything else. So yeah, all right. We will try it. We will try it, but yeah, we will try it. Expect a long response, 30 second or to some minutes, possibly freezing or swapping, system lag. And on top of it, I would have to, you know, record this. Recording also takes up your CPU and all. So I'll probably figure out how to record it without using much of a CPU. Well, after figuring it out, you have to do multiple things. If your goal is for image generation, this model is not what you want. What you should do instead is, stable diffusion, a lightweight variant that is comfy UI. And it's without a GPU, very slow, like minutes per image, like 10 to 20 minutes, as I've said, but it generates it and without actually freezing and all. So for vision, image understanding, use this. For text, use this. And for image, use Cloud or Google Colab. Well, we can't use Google Colab because, you know what? I'll try a workaround so that I can at least show how to generate this image. There's nothing to show about, but yeah, still, I'm very curious of whether it'll be able to generate it or not. So OpenAI capabilities, image generation, image.py, and we will save it like this. Let's save it over here, image.py. Oh, not over here, but at the top of it. I want a comment saying that download this model. Ollama pull and the model name. Okay. Now shall we move on? So supported image, model, prompt size, and yeah. So now V1 response is another API. So it's, trying to very much copy how OpenAI gives you your API and all. So that you can run local models wherever OpenAI is supported or not. So yeah, you just have to change the base URL to 11434 localhost. That's it. Everything else will be supported by default. See, it's telling me that I can change. So if I have installed Llama 3.2, but let's say I'm using some sort of application that really wants GPT 3.5 turbo only, it'll only run on that. So what I can do is actually copy this Llama 3.2. It's just changing the name to GPT 3.5 turbo. It's doing nothing. The file remains the same. The saved tensors file remains the same. Everything remains the same. It's just the model names get changed to GPT 3.5 turbo, and we'll probably use it like that. Not much of a problem. So if I, let's say, do this, let me do it. Oh, Llama 3.2 is not found. So what we'll do is we'll take Qwen 0.5p as always. So it said it copied. Now if I say Ollama ls, we'll see GPT 3.5 turbo. And it'll be so embarrassing because it does not have anything, not even billion parameters, just 600 million parameters. Yeah. So it says, hello, how can I assist you today? That's it. That's it. A single setting context size. So the Ollama OpenAI API, sorry, the OpenAI API does not have a way of setting the context size for a model. So if you need to change the context size, create a model file which looks something like this, and you can, either use set num ctx for context, and you can change the context size to anything that you want to. And we did it, so we don't want to do that again. But we can set it like that and then use it probably. We will not do that. Now it says Ollama is also very compatible with Anthropic. So now this doc will show you about Anthropic compatibility. So Ollama provides compatibility with Anthropic Message API to help. Okay. Now to use it, you have to say authentication, and well, authentication, since you don't have anything and it will be ignored, just say Ollama or anything. And base URL should be changed from Anthropic's URL to localhost 11434 so that you use Ollama as a base URL. And the same thing, a v1 message, like this, but just import Anthropic as a library. We will not do that right now. Streaming, again, like this. Tool calling. So, yeah. But where's the tool? We get weather is the tool. And it requires a location. So tool calling can be done with this. So recommended model for coding use cases, models like GLM 4.7, MinMax 2.1, Qwen 3 coder are recommended. So to download any models like that, just say Qwen 3.5, 3 coder, or well, never use a cloud model. I would not prefer it, but if you want, you can. But then that would not remain an offline Ollama model. It would be online. So that's what you are trying to avoid. No. So note that Qwen 3 Coda is a 30 billion parameter model requiring at least 24 GB of VRAM to run smoothly. And I have only 16, and that's not also VRAM. VRAM is like GPU's RAM. I have a DRAM, that's dynamic RAM. More is required for longer context length. Now quick setup, use Claude and give it Anthropic code, whatever. So there's sort of workaround when Claude was not supported for, Ollama. I think now it is. You don't have to get this deep into this workaround. But yeah, it was good. Now we will see 12 endpoints provided by our Ollama, and that will be end of the video. So what we have is we can use API generate and a post request to, well, generate a message as always. Okay, so let's clear everything out. This is how we used it. Do we have Gemma 3? We have Gemma 4. Not too latest. Till it's generating, we shall see how it will respond. So 200 means our request was successful. We got a response. And this is how our response will look like. Created at, and the response will be in a string. Thinking will also be in a string. Done true because we are not streaming. So yeah, done reason just to stop. So we stopped. total duration, whatever. All right. Log probes. So we didn't get this log probes for anytime soon. So I don't know. Okay. So now see, we had a criteria, or what do we say it? Uh, well, let's say it criteria for now. All right. So like we had to send model and prompt to run. Well, we had to send model and prompt to this API generate endpoint so that we can at least get a response from it. But if we want to just initialize this model, Gemma 4, what we can do is send nothing as a prompt, but just send model Gemma 4 and it will be loaded on our memory so that it's ready to run without any latency at all. Okay. So yeah, we can use it like this. So model is a string that is required. It's compulsory. Without model, you cannot send anything. So model name is required. Prompt will be of type string. It can be required if you want a response. If you just want to load it, well, not really. So prompt is the text for model to generate a response from. Suffix, you can write suffix and whatever the suffix is. It is used to fill in the middle model text that appears after user prompt and before the model response. Okay. So text that appears after the user prompt, but before the model response. That's suffix. I think that was thinking. I'm not sure. Images. Images will be also of type string. So yeah, because base 64 is actually characters as in string. So don't worry about it. Base 64 is sort of a large string with some random characters and you have to convert it to get an image, JPG or something like that. So base 64 encode an image for model that supports image input. All right. Format, you can specify the format can be string, object, isn't it? Now structured output format for model to generate a response from and supports either the string JSON or a JSON schema object. Like we have sent directly an object that is of type JSON. And we got a response in that format. Now system strings is something like system prompt for the model to generate a response from. Stream can be, true or false. So whether you want to stream or not, it depends. So stream is true by default. And when true, it returns the stream of partial response. I think it's false by default because, we'll get a response and it will not be in the stream. We have not defined the stream. So it will be probably false. This is wrong. Stream is almost false in my case everywhere. I don't know about you now. Now think can be also Boolean, true or false, but in case of GPT OSS, it can only be high, low, or medium. It cannot be true or false. Okay, so it can be Boolean. So when true returns a separate thinking output in addition to the content and can be Boolean, true or false, or a string that is high, medium, low, or supported model. All right. Now raw can be there as Boolean. So when true, returns a raw response from the model without any prompt templating. Now what does that mean? I don't know. Keep alive, we've seen that. Keep alive 0 is to unload immediately, or we can say 5 minutes, or we can say -1 to let it load and let it remain there. Don't unload it at all. Okay, so keep alive can be used. It is of type string or numbers. Well, I think it depends because if you're saying 5M, then it must be a string. If you're just saying 0, it's number. All right. Objects. You can pass objects as objects. Now runtime option that controls text generation. So option, the option was object. So options object, it is a runtime option that controls text generation. So it has option seed, that is an integer random seed used for reproducible output. So if you set a seed up to 49, then for the same input prompt, you will get a same output. That's what I've read. For temperature, for creativity, so control randomness in generation. Higher is more random, lower, like 0, is less random. That's it. So it's from range 0 to 1. And then option top k is of type integer that limits the next token selection to the k most likely. K is, I guess, kappa. I'm not sure. Option top p is a number that, cumulative probability threshold or nucleus sampling. Then we have minimum p, that is minimum probability threshold for token selection. Then we have stop, option stop, that stops the sequence that will halt generation. Stop sequences that will halt generation. Okay, and is of type string or a string array, whatever. Num_ctx, we know it is like context length size. We can define it, number of tokens that it can take. We can set it from options.num_ctx. Options.num_predict does what? It says maximum numbers of token to generate. So let's say we want output or a story in 10,000 words. So I can say, well, generate a story with a num_predict of about 10,000. All right. Log probs is a boolean, whether true or false. So whether to return a log probabilities of the output token or not, it can be enabled or disabled through log probs. And then there is top log props, that is numbers of most likely tokens to return at each token position when log props are enabled. Then as a response, we can get model that is string created at string response created at is a ISO 8601 timestamp. So yeah, it was a different format for the timestamp, but now we know it's standard format 8601. Response is whatever the model generated the text. This is what we are talking about when model responds to us. So I hope it did. Yeah, so something like this. Oh, damn. It was stream is equals to true by default. Sometimes this works, sometimes it doesn't. I don't know what is the reason or why is that the case. Okay. So response is something that you get over here. So you will see model, and that is Gemma for created at, and the timestamp that is an ISO 6801. 6801? 8601, sorry. Then response is something that it will send every time, response or cumulatively response, whatever. Thinking, if it's thinking, it'll send you that. Is it thinking? No, it's not. It's just directly responding to you. Yeah. And it's going. All right, let it run. Then done is a boolean that indicates whether generation has failed or not. Done reason can be the reason for the generation to stop, and total duration is time spent generating the response in nanoseconds. Now, load duration is something that you get the time spent, loading the model in nanoseconds. Prompt evaluation count is something that you get for the number of input token in the prompt, and so on, other criteria that you can learn about. Okay, there are multiple criteria. Now let's directly get from generate to chat. Now over here, it was generate earlier, now it's chat. What it does is it generates a text, generates a chat message. So since these are post request, we have to use curl. For get request, we can directly select this link and go to our browsers mostly and paste it. And see, this is what we get. We get tags for like all the models available to us. So we have GPT 3.5 that is actually copied from Qwen. Yeah. Then we have 5.3 mini and all these models that we have right now, and each and every details about it. Okay. But let's get back to chat and let's see and finish it out. So this is chat. We can chat it out, models and message, and inside message we can have role or content. But in generate, we had model and prompt. All right, model, prompt. In chat, we have model, but message. And inside message, we can have role, that is user, content, whatever the prompt is. Okay. So this is API chat. Now it generates the next chat message in a conversation between a user and an assistant. Okay. And the body, what it takes as an input in body as in request is model is required. Message, that is an object, is required. And tools, if you want to send a tool, you can. Format, that you want a JSON schema or not, available. Options, as always, is available. Think whether to think or not, it's available. Whether you want to keep the model alive or not, it's available. Everything else that we have seen is same for this one also. But what changed is then there are two things that are required in our request, that is model and message. Okay, for API chat, two things are absolutely required: model and message. That's it. Anything else is optional. Now we know generate, we know chat. If you want, we can generate it. Not a problem. See the context we get. Damn. This long of a context. Yeah. Let's change the model from Gemma 3 to Qwen. Okay. And we can specify what? After message, we can say that we want stream is true. Oh, so fast. And same, we can make it false. That will not stream, but will give a response directly like this. Nicely done. Okay. So now let's get back to embed. That is, we have used embedding Gemma that converts whatever you give it to embedding, like numbers. I can save them, use it probably. So what is required is model and an input, that is a string or string object. So text or array of text to generate, embeddings for. Now you can truncate the boolean, the truncate, that can be a boolean, that is true or false. So if true, truncate inputs that exceed the context window, and if false, returns an error. So context window is, let's say, 4,000, and we have a text that is of 10,000. So the rest will be truncated if it's exceeding the context window, that is 4,000. So 6,000 will be just truncated. Now dimensions. So number of dimensions to generate embedding for. It's vectors. So yeah, it makes sense. Now keep alive, if you want to keep that model alive. Options, as always. Response, what you can get as a response is model, and then embedding, that is numbers, total duration it took, load duration, prompt eval, and so on. Now tags, we've seen how tags works, but we can use CURL as well to see how tag works. And we get the whole response about what sort of model we have and every detail about it. Or we could just go to our browser, to this API tags on localhost, and we will see it very pretty printed. That's exactly what we wanted. Okay, nicely done. Let's get back and see. So since it's a GET request, we cannot send anything except for going to the link. So response we'll get is an object that will show the model name. Model's name is a string that gives you the models. Models.model is again model name. Let me see. Model name is model name, and then model dot model is again the model name. Why? Why? I don't know. So why do we do that? I'm not really sure. Remote model. So name of the upstream model if model is remote. If it's not, well, you will see nothing. Yeah, I don't see anything. What else you can get? Let's open up side by side. Yeah, so that we can compare. What are we getting? Yeah, so model name, model. We are seeing that. Remote model, no. Remote host, no. Modified at. We directly see modified at, and it was modified at, you know, whatever the time is. Timestamp is in format of ISO 8601 format. Model size. So what is the model size? It's in mostly, I think, megabytes. So total size, it takes in your disk in bytes, not megabytes, but bytes. So you have to divide it by number of zeros. So about 1, 2, 3, 4, 5, 6, 7, 8. 8 zeros to get GBs. Right. Now model size as an integer. And then you get model digest, which is SHA-256 digest identifier for the model contents. Okay, so I think it's because of security purposes or what? Why are you using SHA-256 as a model digest? I am not sure. A model details like parent model, format, isn't it? All those details. So format, family, families. Oh, oh. So if there are more than two or more families, yeah, it'll be shown in families. That is array. And then parameter size, that is 620 million parameters for GPT-3. It's a misnomer. We have created this one. All right. Quantization level, that is Q4, Q8, whatever. Q4, Q4, Q4KM. F16. Whoa. F16. Q40. BF16. Oh, oh. What else? What else? KM again. KM. Yeah. All right. Next is again a GET request, but at a different link. That is API PS. Remove the curl because we curl it. Now, if any model is running and is in process, like if we run, let's say we run a model Qwen 0.5p, and now if we see it, we'll probably see that model is running. That is Qwen 0.5p. Size is this much, digest, and everything about that model. If it's running, size of VRAM, well, 0, because I don't have a VRAM. Context length, well, how can I increase this context length? I was not able to do it yesterday also. We decreased it from some 32,000 something something, but now we cannot make it, back. Now we see what it sends as a response. So this is over here. This is what we get as a response. Size of VRAM. Well, I have 0 because no GPU at all. So response, you can read about it. You can directly see from here. This is exactly what you get as a response. Now, this is a post request. All right. So you cannot just directly copy and paste this on your browser. So let me do it for you. So you might be curious. What about we do it? What will we get? We'll get nothing except for 404. 405, method not allowed. Yeah, not 404. Method is not even allowed because it's a post method. So let's close it. And yeah, let's send this request. So what it will do is for Gemma 4. Oh, damn. This is too much. This is too much. WL copy. Yeah, we have copied it. Clear this and let's paste our copied file and format. So this is what we see. So we see all the licenses, like every detail about that model is what we get. And after the license, we see the parameter that is temperature, template that is prompt, details, parent models, family, format that is gguf. You know, there are multiple formats like MLX for Apple Silicon, gguf as a normal for everything, Apple plus whatever you can use. Yeah. Model info, it has all these infos, like so much of info that you can get directly. Tensors, and you have a tensor info. Something change every time. I'm not sure how it can be useful, but it definitely is useful for someone who is trying to analyze it, create their own whatever. But I'm not sure how it'll help us probably. And at the end, we get the capabilities that it's a completion, vision, audio as well. I haven't sent audio to it. So if I try sending an audio to our model Gemma 4, let's run Ollama Gemma 4, run it. And do I have an audio? Let me see. Unless I don't. We got a test.wave and we want to check it out whether our Gemma 4 can actually, tell us what is there. What is in the audio? Because there are other, transcripting models that can transcript your audio directly to a text, and then you can send the text to your LLM or so on, like Fast Whisper or Whisper, whatever. Now, let me try whether it can do this directly without anything else. Right. Now it has added the audio. Okay, let me see what it says. And just for your context, it says hello and this is a test.
Hi, I am a test audio.
What the hell? I said test.wave, it also opened up test.jpg. I don't know why. Because of the same name, I guess.
Hi, I am a test audio.
Does that happen a lot? It's something new again. We are learning new every time. Like everything we do, it's something new to us. So exactly, this is what it says. Hi, you are a test audio. Not exactly. What was it? Let me know.
Hi, I am a test audio.
So it says, hi, I am a test audio. Not, hi, you are a test audio. But all right, this much is understood because, yeah. Hi, you are a test audio. Okay. So we'll take it as a win. So it can actually process our test audio. So if we make something like, okay, so we got another audio that is snake.wave. And
can you create a
I'll let
snake
you
game
hear
in HTML
what it
standalone
says.
file?
Yeah, so it is giving it instruction. Can you create a snake game in standalone HTML file? So let's directly give that audio to it as a snake, SNAKE, not wave. So it has added the audio. Let's see if it can process and respond to that audio. So let's start. Oh, did I ask a question or did I set it as an instruction?
Can you create a snake game in HTML standalone file?
So instead of saying, can you create, I would say, create a. We got another audio that directly gives the instruction
Create a
that
snake
create
game in
a snake game,
HTML.
right? Snake one.wave. Yeah. So let's directly send that audio to this as a prompt. Snake.wave. I don't know why it's taking so much, Would you like me to include any specific? Sometimes it just start processing it, sometimes it doesn't. I don't know why. Is it because of the audio file or something like that? And now I had to like explicitly say like created and with the spelling wrong. So don't worry about it. It will actually create it. So we'll stop it from here. And yeah, our Gemma 4 model can even take an audio to process. So that's something interesting that we learned. So show is like shows the model details, like we have used, a forward slash show info. It's the same thing, like show info, but it has a bit more to it. Yeah, we see the capabilities that is audio, tools, and thinking, isn't it? Whereas most of the small models with small, you know, let's load a model called LLaVA LS. Model name is Mistral, isn't it? So it cannot handle the thinking, so it did not got loaded. How about I load Qwen 3.5? Oh, yeah, load. Load is the command. So it's loading the model. Okay. Now this is a thinking model, so it will get loaded probably. I will see what are the capabilities of this model. Is it able to process audios or not? I know it can process visions, but what about audios? And I really am curious about how does it do that? What happens at the back of? I will say show info. Oh, not info, but info. And no, it has completion, vision, tool, and thinking. And nothing else like audio as well as. Okay, so only one thing is missing over here. Not bad actually. But again, Gemma 4 is the game changer, I think. The capabilities of Gemma 4, if it can even process the audio. So it's like I don't need a fast whisper or models like that to convert my audio to text and then send that text as it is in prompt. So that's actually a good thing. Why? Because the latency gets reduced, no? Like fast whisper also takes a little bit of time to transcribe what you've said and then sending that to a model. So in this show post request, what we just want to send is the model name, nothing else. The model name is absolutely required. We can say verbose or not. We can. And the response we'll get is this whole thing about model info. Now next post request is to create. So what it does is it creates a model that we want, like copy, isn't it? So it can take a model, like say Gemma 3, Qwen 0.5, and then we can name it to something else, like our model called Tommy. Let's create a model called Tommy, right? And then we can give it a system sort of prompt that this is what you are. Let's do that. But instead of doing it like this, normally, like a curl command, we'll actually create the script like we did earlier as well. So get into curl ls. Now let's create 4.sh because it requires some focus from the side. Qwen 0.5, 5b, isn't it? Let me see. Ollama ls. Check. Ollama ls. Qwen 0.5b exactly. Alpaca, no. You are Tommy. Sorry for the name, but a helpful AI assistant. You only answer with emojis. I don't know whether it can, follow this or not. But let's see. If I make it runnable, chmod plus x and what is it? 4.sh. Now let's try running our 4.sh. So it says status using existing layer and creating a new layer, writing manifest. Okay, so it was a success. So if I do Ollama ls again, I'll get my Tommy. Over here, it's a Tommy. And if I say Ollama run Tommy, now I can say, who are you? Oh, yeah. Like it was such a small model that it was not even able to see. Oh no. A model created by Alibaba Cloud. That's not what I sent you for. But yeah, since it was such a small model, it couldn't take the context of it. So let's do the same thing, but with a bigger model. So before that, let's remove the Tommy for now. Ollama RM Tommy, because we'll create Tommy from ground up, but with a better model. Better model like Gemma 2 billion parameter. Which one should we use? Let's use Gemma 4B. It will take a little bit of more time, but probably this is the best we can do. And run it. So it's a success. If I do Ollama ls, we'll see Tommy, but now it's 9.6 GB, which means we got a Gemma. All right. Now, if I try running Ollama run Tommy, if I ask who are you, I expect it to get the who are you from system prompt, like I am Tommy, I'm your AI assistant, something like that. And since it has, larger context window, it can probably answer. Now it has to load, so it's taking time. So let's give it time. So it has loaded. Hi, who are you? What's your name? Yeah, it's answering an emoji. So it says hi, and then something like, is it male? Yeah, this emoji is for male, no? And then a robot, and then a star. Nicely done. It's actually following our prompt. If I say, what can you do? I don't know. This was interesting. Light bulb idea, which means it can think, it can write, and is thinking. It has books. It can provide stats. Okay, okay. I got you. Do something. I am not sure what I should make it do. Like, what can I do from this emoji? So, do something for me. It says okay, but nothing. Okay, tell me a joke. What? Oh, it's interesting, but at the same time, it's irritating. Well, because of our system prompt, because we've sent a system to be, use only emojis. So it's following our system prompt. So that's our bad if we don't want this response. Uh, a long response. Response. Hmm. It was a bit long. Yeah. So what do you think about my Tommy? Yeah. Tommy the assistant. Nicely done, actually. It's nice. So you can create a model according to your own self. You can change the system prompt of whatever you like. You like a teacher, not an AI assistant, and you want it to be strict and ask MCQ questions, like whatever. You can do it. All right, you can do it. These are all the. Let me quit. But it was interesting. I can only say that. But what is required is model string, and from you can, like, you've created a model file, you can do that same. So from is the string that is existing model to create from. Template is the prompt template to use for the model. Licenses, you can give it a new license if you want. Otherwise, it'll take from the previous license. System prompt to be embedded in the model. You can do that. It'll be better. You can fix the parameter, key value parameter for the models. You can say message and message history to use for the model. Okay, you can quantize the model a bit more. Okay, stream, you can, yeah, stream is something we all know about. Okay, so we can create our own model. Now, what's copy? So, copy is the same thing, but it's just, taking the source, giving it a destination, and saving it as a backup so that if we change like parameter or something like that, we can always take the backup always. So as we need existing model name and new model name to create, and it'll be copied. So let's copy a small model, that is BAC. Nice. Qwen 0.5 B backup. And destination, can it be a path or what? Qwen 0.5 B. Let me see. Source can be existing model name, new model name to create. Okay. Destination is new no model name to create. And that's it. And if I do Ollama ls, yeah, I see my backup model. Next, we can directly pull a model, from the internet. We don't want to, so we will try pulling a model that we already have, that is Qwen 0.5 B. So it's pulling manifest, and this is how it does, and it's a success. Yeah, we can move on. It was pulled 8 seconds ago. Now, if I run my Ollama run, did the context window of it sort of reset or not? Like it was something around 32,000 or 37,000. So info. Context length. Yeah. So context length. I guess this is what we want to see, no? Let me see. Ollama PS. No. This is not exactly what context length is still 4096. Okay. I think I cannot escape from there. So we got a success. So if we are in a browser and if we don't have any model, we can directly fetch it like this or directly install it. It'll probably take some time. If it's on server, some backend, it can do that. Interesting. Actually, it's very interesting. So nice. Response status string push. Now what it does is it pushes a model. So let's say we have a model, my username, my model, and what it does is API push a model. Non-streaming, stream is false, push a model, but what does it do? Name of the model to publish. Oh, push. All right. So if you've created a model like Tommy, I can push that model to Ollama so that I can download from there anytime soon. Anyone else can also download like a private model, but you'll need to be signed in for that. So if I try pushing my Tommy model, my username. So I don't have a username first of all, and second of all, let's try pushing just Tommy. Isn't it? That's the name, Tommy, and I'll get an error. 403 error saying anonymous access denied. So you cannot be anonymous and then access it. You have to be signed in and whatever the username is. Then after you can say your username, whatever you got the username, and then whatever your model name is. Then only you can push it. All right. So insecure, true or false, allow publishing over insecure connection. So if your connection is insecure, like it's not stable, it can get disconnected. So yeah, it'll probably take precautions for that. Now you can delete a model. Let's say I want to delete my Tommy model. I can delete it through an API like this. And if I do Ollama ls, I'll probably not see my Tommy. I'll miss you, Tommy. But yeah, we have deleted it and we have to just send the model name to delete and the response will get either it's deleted or it's not. Let's say if I try to delete Tommy again, which is not even there, so it will probably give me an error. So error, Tommy not found, isn't it? So either it will say the success message or it will say the error. Now get version. Since this is again a get request, we can directly take the link, isn't it? And we can paste it in a browser, run it, and it will give you the version of your Ollama. Or, well, you can curl it, not a problem. And you get a version of your Ollama. So I think this is it. This is the end. And we might have covered everything. In the next video, I might use these endpoints in Fast API and create a web app for all of us. And I'll probably try to publish it somewhere so that I can, install certain models, access those models for free. Well, we'll try. And the server, the backend will be free like Render or Railways, depends. And I hope it'll work.